Everyone, welcome to my talk. My name is Ala Tabak, and today I'd like to talk to you about why and how you should nuke your AWS account. Let me start with a short survey. By a raise of hands, how many of you ever forgot a running EC2 instance in AWS? Okay, so you can see it's a shared problem. Hopefully after this presentation, you can buy one of these from the money I'm going to save you. Of course, I mean the jackets, not the car. So I work on a project called OpenShift Cluster Manager, OCM for short. We install a lot of OpenShift clusters on GCP and AWS, mainly on AWS because of Red Hat's offering. And many of them sometimes, because we test a lot, we use a lot of versions. Sometimes clusters just fail from deleting, and we leave them running in AWS. So try to delete a running OpenShift cluster in AWS. You have to deal with a lot of dependencies. You may have seen it if you ever try to delete an EC2 instance. You delete it, you forget to delete the volume or the disk or anything else. So try to understand all the topology of all the resources in AWS. It's kind of hard, and you need to understand whatever resource depends on another resource, and you need to be aware of the right ordering of deletion. So for example, when I started doing this manual work, I tried to delete a VPC, for example, and deleting a VPC blocks me from, deleting the VPC is blocked by deleting the subnet. And then I couldn't delete the subnet because the IP address was being used. So it became a real problem. And when I first started doing this manual work, I figured, well, I should better automate it because I'm doing it more frequently. And once I did it over and over again, I understood that I also need to handle multiple regions, and I need to, of course, be aware of all the dependency graph, and I need to repeat it again and again. So this became kind of an agonizing task, and I thought to myself, well, I should probably avoid reinventing the wheel in this case. And I thought somebody probably already resolved this problem before. So I did some research, and I found there were actually several tools for handling this kind of situations. And one of the best one I found was AWS Nuke, which I'd like to share some thoughts about with you today. So what was interesting, I went online on their GitHub repository, and it's an open source project, and the interesting part was that they're dealing with kind of the same problem that we're dealing with, only with Kubernetes clusters. So they're installing Kubernetes clusters and having the same problem with cleaning up their AWS account, and we're dealing with it with OpenShift clusters. So it was nice to see, and I'd like to share with you how you can use that tool to clean up your AWS account and reduce your spend. So to use it, you start with defining a config file, which is basically a YAML file. You set up which regions you want to clean. Some AWS resources are tied to a specific region, some are not, are global. So you just write global as a region, and then you list the accounts that you like to clean. And then you just type AWS nuke -c, and then a path to the config file, and then -- profile, and that contains the AWS profile that the AWS nuke would be using to connect to your AWS account and clean things up. So if you download and run this tool, you would see an output which kind of looks like this. What AWS nuke would be doing, it would be connecting to your AWS account. It will scan all the resources that you have on your AWS account, and it will list whatever it finds for, which is candidate for deletion. And by default, it will not clean anything. It will just list all the resources. If you do like it to do a cleanup, you would need to add a -- no dry run flag that will prompt you if you like to actually do the cleanup process. And if you hit yes, then it's going to do the actual cleanup. Do take in mind that some resources require some waiting for them to get deleted. So what the AWS nuke would be doing, it's going to try delete some resource, If it's going to fail or find it again on another scan, it's going to reattempt deleting it, and it will try over and over again until it deletes everything that you asked it to delete. There's also sorts of filtering options for that tool. Like in my example, I'm trying to delete only, for example, ELBs or EC2 instances, S3 buckets, so I can list them all under the target section of the config file. I can also ask the AWS Nuke to filter out some resources. So for example, in this specific example, I'm avoiding cleaning up my own credentials, my own admin credentials to the account. So I can use that also as filtering out these kind of resources. There's other types of filtering options like by value, by regular expression date. I encourage you to go online and read about them. So we started integrating with this tool, and everything went butter smooth. We have a nightly test suite that runs overnight. It takes roughly 2, sometimes 3 hours to run. And then when developers came in the morning, they come, they see the results, and by that time, the cleanup process was cleaning all the stale resources on the AWS account. And it worked good for a while, and then we hit the wall. What happened was that developer came in the morning. He saw some environmental failure. Sometimes it was something that a developer fixed, and they wanted to rerun the test suite. Now, imagine tests are running, creating clusters on AWS, and at the same time, the cleanup process was deleting them. So obviously, that became a problem. So we started thinking, how can we avoid deleting resources that are actually being used at the same time? And we figured we couldn't really know if a resource in AWS is actually being used. So we started thinking, how can we avoid this problem? And one of the things that came to mind was, well, we don't want to rely on the test side. The test can fail, it can crash, it can run from my laptop, and I can be offline. I couldn't really rely on asking, are you using this resource? There's no one to talk to at that point. So we figured, well, the test runs for 2, 3 hours, sometimes 4, but never more than 5 hours. So if the test goes over 5 hours, it will time out, it will terminate. So we figured everything that is older in AWS, older than 5 hours, we can safely remove it. We have a dedicated AWS account for the test, so it's safe to remove. The problem was that some AWS resources has a field of creation timestamp, but not all of them. And we want to overcome this problem, and we figured, how about we'll add a first seen timestamp, and while we are scanning the resources, and if we do it frequently enough, we can add this tagging to each AWS resource. And running this frequently enough, the first seen timestamp will be pretty much close to the creation timestamp of that resource. So what we are using the AWS client that the AWS Nuke is using to connect and talk and scan the AWS account. We are using that client to also tag the resources while it scans them. So the AWS Nuke will be connecting to the AWS account. It will start scanning all the resources. While doing so, it will tag first seen timestamp on all of them. And then once it finds a resource that is older than 5 hours, it just adds it to the resources that are candidate to get deleted. And that worked great for us. We are working with this method for a while. It reduced our spend from looking like this every time we hit a quota issue, or we got an alert from AWS that we're spending too much money, and then developers came and started manually deleting stuff. We went to this, so it's very lower spend and much more untrendy, I would say. So let me summarize. One thing would be trying not to invent the wheel. If you're working on a business problem or another problem that is not directly related to your business, maybe someone else already solved it, AWS Nuke is a great tool for cleaning up AWS resources. It's open source, so you can contribute as well. We are contributing to this project, and then everybody benefit from that. So I encourage you to look into it. I'll take any questions now.
Okay, so you mentioned the filters.
Yeah.
Do you have some experience with filtering according to text?
So we have some filtering according to text. Oh yeah. So the question was, there's all sorts of filtering options in the AWS Nuke. One was, the question was if there's any options to filter by text. So there is an option to filter by value, for example, and in this case, this one's for example, this is a filter that is filtering out my user. So it's basically a text filter.
I mean text as tagger. You can tag your service, and users don't care about it, and you don't know which if it's useful or not. So how to like delete all the resources without tags, like
Without tagging?
without tagger.
Okay, so the question was how to delete resources without tagging. Okay, so if you don't want to use tags, you can consider one of the other options. For example, you can use a regular expression or a date, if you like. There's many options, and if none of them suits you, that's the fun of being an open source project. You can contribute to it, really, and we will benefit from that as well. Any other questions? Okay, guess not. Thank you.
Okay, good afternoon, everyone. My name is Konstantin. I work for IBM Germany, and I'm also a Red Hat partner engineer. And for the last 2.5 years, I was working on enabling OpenShift service mesh on S390X architecture. And in my presentation, I'm going to share my experience about that. So first, I will make a quick overview of service mesh architecture. Then I will talk about the differences in implementation on x86 and S390X platform. I will also talk about the features that were previously were enabled only on x86, such as load-JIT and WASM filters. We'll talk about boring SSL library replacement, and we'll talk about future and possible enhancement. So what is a service mesh? Service mesh is a dedicated infrastructure layer in a microservice architecture that enable you to add capabilities like traffic management, observability, and security without adding them directly in your code. So therefore, the microservice developer can focus on business logic only. So the main component of service mesh is Envoy proxy that runs in a sidecar container alongside each microservice rather than within them. And those sidecar containers form a mesh network. So currently, there are 3 implementations of Envoy are available. First one is upstream Envoy. It is used as a base for Istio service mesh and based on boring SSL library. The next one is Maestro Envoy. It is used as a base for OpenShift service mesh product by Red Hat. And the main and the biggest change in comparison with upstream Envoy, it is a fork of upstream Envoy. And the main biggest change is that boring SSL library is replaced with OpenSSL. And there are also changes that enable build on other than x86 platforms such as S390X and PowerPC. And the third one on Envoy-OpenSSL, it is also based on OpenSSL, but the boring SSL library is replaced with OpenSSL using more advanced technical solution. I will mention it in the next slides. But currently, the status of this project is work in progress, and there are no working versions for any platforms. So Envoy is written in C++, and Bazel is used as a build system. It has approximately 60 external dependencies, and each of them is a separate open source repository. Some of them are pretty big and well known, such as Google V8 JavaScript engine. From the security perspective, the Envoy build is being done in an offline environment, and all code, including Envoy itself, on all of these dependencies are being built from source without using any pre-built libraries or binaries. And so the build takes more than 1 hour, depends on the hardware available on the build machine. So what is S390X platform? S390X is a Linux operating system that is compiled to run on IBM mainframe computers. And there are situations in which the code that is compiled on x86 and it just works. And if we are trying to compile this code and run S390X, it crashes. So the most frequent reason of such crashes is different in endians, which is the order of bytes in computer memory. So S390X is big endian, x86 is little endian. Another type of problems that we have on S390X is C compiler errors specific to S390X. So the build is specifically configured in that way so that most of warnings are considered as errors, And here you can see the example, a real example of such errors, and the root cause is that character types may be different on different platforms, signed or unsigned. The last class of problems is Bazel build errors, and they happen because of some of Bazel toolchain do not support S390X or don't have binaries available for S390X. So by design, all communications between the microservices are encrypted, and Boring SSL is used in upstream Envoy as TLS library. So Boring SSL is a fork of Google's fork of OpenSSL, and the problem is it is not supported on S390X, and its community doesn't accept any S390X changes, and Envoy community doesn't want to support OpenSSL in addition to Boring SSL. So on S390X, we have to use either this one or this one, the implementation. And the last one, it is not ready. So currently, Maestro Envoy is being. The difference between them is how OpenSSL is replaced. So in Maestro Envoy, all calls to Boring SSL methods and all headers and everything is being replaced manually by Red Hat Envoy team, and this is a huge amount of work. And to reduce this amount of work for each release, currently this project, Envoy OpenSSL, is being developed. So the main idea is to have so-called compatibility layer for Boring SSL to OpenSSL. So it provides an implementation of Boring SSL APIs sufficient enough to build Envoy against it. So there is a mapping between Boring SSL and OpenSSL method, and when Envoy calls some Boring SSL method, then corresponding OpenSSL method is loading dynamically from OpenSSL shared library, so using DLOpen, C function, and others. You can read more details by clicking this link. So initially, GCC was used as a main build tool in Envoy, but about 2 years ago, the community changed the build tools, and they switched to LLVM, Clang, and LSD as a linker. And this caused a lot of problems on S390X, because LLD is not supported on S390X, so we had to switch to LD.Gold. And there were more problems. For example, integrated assembler wasn't supported. We had to disable it on S390X. Then we had to define manually missing types, numeric types, replace them with the existing double or float in Clang. And we have to fix new S390X specific warnings by either changing code or disabling those warnings. So here is the summary of Envoy dependencies that were changed or replaced to enable the build on S390X. So first, Boring SSL is replaced with OpenSSL. Another project is Luajit, is a compiler for Envoy filters on Lua language. It was replaced with Luajit 2, which is OpenRestis implementation fork of Luajit, and it supports S390X. Another problem was NTLR parser dependency. We have found a bug that when passing deliberately incorrect string to input as an input, Envoy crashed and parser crashed. So by debugging points to some internal functions within libstd C++ string, and I couldn't find the root cause, but I could find only workaround to disable string length optimization during the build. And now if hacker passes incorrect input, Envoy won't crash on S390X. So another change was to Google Cache, and in its HTTP2 implementation by fixing endianness problem by swapping bytes. And the last change was to on WebAssembly extensions. So WebAssembly or WASM is a portable binary format for executing code, and it is run in a memory-safe sandbox. So user can write filters and compile them and dynamically load into Envoy as a WASM modules without stopping Envoy or rebuilding. So currently on S390X, we support two WASM runtimes, Google V8 JavaScript engine and WASM time. And to support them, we had to change proxy WASM Envoy dependency. Let me tell a little bit more about that. So initially, when we tried to build WASM modules on S390X, we got first build problem, because we could build using only extensions written in Rust language, and we couldn't build extensions written in C++, because it requires EM script and toolkit, which is not supported on S390X. But even if we build them on x86 and copy WASM modules to S390X, we experienced a crash, WASM VM crash. After investigation, the problem was that WASM module always, by design, keeps all instructions in little endian format on any platform. And WASM runtimes, for example, Google V8, supports this on S390X, but Envoy proxy WASM didn't support it, and I had to find all places that serialize deserialized data to WASM module and read that reads or writes data from or to WASM module between proxy WASM extension and WASM VM. And proxy WASM maintainers were S390X friendly. After several code reviews and several pull requests, they finally accepted all changes, so that now WASM extensions are supported in Envoy on S390X. You can read more detail by clicking this link. So for now, almost all features that are enabled on x86 are supported on S390X, but we can improve something. If we enable EM script on S390X, then we could build and run all tests from master Envoy repository, including building WASM in any language. And the next improvement could be the real fix, providing real fix instead of workaround for NTLR4 parser. Then also contribute to Envoy OpenSSL implementation, and monitor the development of Embed Mesh, which is a new proxy in Istio organization, and there is no working version currently, but it is still under active development. Okay, so that's all. Now almost all features are supported on S390X, but the permanent maintenance work is required, because every day new changes are being added to Envoy and to its dependencies, and potentially any of this change could break S390X build. So thank you for listening. So if you have new questions, you can find me later. Or if we have time now.
No, we are out of time.
Oh, okay. Okay, then feel free to contact me.
Okay, hello everybody. My name is Ori, and I'm excited to be here to share a success story of my team. It all started when we decided to expose our service to new audiences, which presented new challenges that resulted in a lower adoption rate. We looked back in the past, and we found out a method from the aviation industry almost 100 years old and adapted it to our service. Does your service or product depend on the user's cloud? If so, maybe you can take some key takeaways from this session. In the year 1935, a prototype Boeing B-17 crashed in Ohio, killing 2 pilots. After that, a group of engineers decided to come up with a new method called pre-flight checklist to ensure the flight safety. This is performed until today before each flight. Pre-flight checklist can include checking the fuel quantity, the baggage weight, the aircrew documents, and more. Like airplanes, our service is also in the cloud, so we decided to adapt this method. I'm a developer in the OpenShift Cluster Manager team. OpenShift is a Kubernetes-based platform that enables developers to deploy their application. You can use our managed service in the link above to create clusters with a single API call, to deploy more machines, to schedule upgrade, to get the latest version, get metrics about your cluster, CPU usage and memory usage, and more. How does it work in a high level? The user is making a single API call to create a cluster. Our service is starting validating the cluster spec, running some business logic, and if everything goes fine, we are continuing to the installation phase, triggering the OpenShift installer, and if anything is wrong, we return an error to the user they can fix and retry again. After 40 minutes, if the installation is successful, you can deploy your application on the cluster. If it went wrong, we get an error, and you have to investigate it and to retry and start all the process again. Up until here, everything worked fine. Then, we decided to expose our product to new audiences, presenting the customer cloud subscription. So on the left-hand side, you can see our previous offering, where if you wanted to have a cluster, we had a pool of AWS account pre-configured and ready. We would allocate one of them, create a cluster, and provide to you access to the AWS cloud, and you can manage your cluster. Now, customer cloud subscription has many advantages. First, this is costless. You have your own customized account. You can bring your own VPC and more. But then all of a sudden, we are starting to see a lot of installation failures. Sometimes the account is not configured or missing quota. I want you to imagine a user trying to create a cluster, and they are sitting, it is moving to the installation phase, and they are sitting in front of the monitor, waiting 10 minutes, 20 minutes, 30 minutes, just to find out that the cluster is in an error state. How frustrating is that? They have now to delete the cluster, delete resources in the cloud, call the support, and start all over again. And there is no guarantee that on the next time it is going to be successful. Maybe something else will be wrong with the cloud account. So this is not a good user experience and probably not the way to attract new customers to our service. So what do? We go back to the pre-flight checklist, and we are adding a new layer in our service. You can see the purple rectangle, the pre-flight layer, where we are making multiple API calls to the AWS cloud of the user, and we are verifying that the account is ready to create a cluster. Like an airplane needs fuel for a flight, a cluster needs resources, elastic IP, EC2 instances, load balancer. Like an aircrew needs documents and permission, our service needs permissions to provision a cluster and manage it in the user account. So from here, we have two options. Option number one, if anything is wrong with the account, we return a bad request, the user can adjust the AWS account and start all over again. We are preventing an installation failure. If everything is fine, we are moving to the installation phase with a much higher success rate. Just before that, I have to say, to be honest, there is a trade-off here. First, previously, we could return a response to the user in 1 second. But now we are making multiple API calls, and it takes much longer. The user can wait up to 10 seconds. The second thing, this is not 100% bulletproof, because we are checking the user account in a very specific time, like a snapshot. So if the account was valid and ready to provision a cluster, and after that we move to the installation phase and something changed, we don't have any protection against that. Let's see how does it look like from the user perspective. For that, we are going to use the UI, creating a cluster, choosing the AWS cloud. Here, in the wizard, we have the option to configure the cluster spec. One option is to choose next and get the default configuration for the cluster. So specifying the AWS account, then a set of roles to grant permissions in the AWS account. And here you have the option to click next and get the default spec. So we're going quickly through this. And then at the last step, we're going to make an API call to create the cluster, choosing the cloud region, the version, setting the machine pools and the network configuration, and so on. In the last stage, we're going to see the cluster spec, a summary, and then clicking create cluster, making API call, and now the pre-flight checks are running in the background. So here in this case, we can see you need one available Elastic IP address to create your cluster. We have just prevented an installation failure. The user can jump to the AWS console. Here in service quota, they can make a request to increase the quota. This is one option, making this request. The other option is to release redundant resources that they don't need. In this case, we are going to release one Elastic IP, and after that, they are going to have enough available quota to provision a cluster. Going back to the Red Hat console, creating a cluster. Now again, the pre-flights are going to run in the background. Once all of them pass, we can move to the installation phase. A closer look at that, how do we get a quota? We have the applied quota in a specific region, in this case 10. We're calling get service quota to get the limit in a specific region. Then for the utilization, we're calling describe addresses with the EC2 service. Once we have the utilization and the limit, we can calculate the available quota and to ensure this is enough to provision a cluster. We have multiple pre-flights for quota, for authorization in the user account. We are also supporting bring your own VPC and validating the configuration for that. To summarize, we decided to expose our service to new customers. It introduced a new challenge. We combined an old aviation method with the Cloud SDK. It increased the product adoption and the success rate. You can find our open source repo, Rosa. This is the CLI tool that we are using to provision cluster, and you are welcome to contribute. This is it. Thank you, and a great time for questions. Okay, yeah.
So it works from console. Will it work if customers provision OpenShift clusters directly from marketplaces of clouds?
The question was, you asked if it works from the console and if it will work from marketplaces in the cloud. So specifically, when you saw the UI, our backend, the pre-flights are in the backend. So if this is from the UI or from our CLI tools, All of them are making API calls to the same backend. And when you create a cluster, trigger the cluster creation, we run the pre-flights.
So pre-flights are actually part of provisioning API. It's not layer in the console which does the pre-flight.
It's in the backend, and it works for the CLI and for the UI.
Okay, great.
Yeah. Okay, thanks a lot.
Okay, hi everyone. Hi dear colleagues. My name is Sergey and I'm working on Linux system roles. And in modern world, diversity, equity and inclusion became a main topic and a focus. And because it's important for all of us to feel comfortable on the projects that we work on, the projects that we use and we participate in. And one of the parts of this is conscious language, which is about using words that are rather inclusive rather than exclusive. And in Linux system roles, we started using a tool that is called Woke to detect language that is not inclusive in our code. So today we will cover first of all, why this initiative is important, and then we'll switch to technical part about the Woke tool itself and its features, about the GitHub action that exists there with Woke, and then about some caveats that we had working with Woke and how we worked around them, and yeah, after this we'll have some Q&A section. Software often uses some words that carry a great deal of emotional and historical baggage. And to be truly inclusive and welcoming, we should try to avoid the use of words that can carry these unintended second meanings. Just to welcome all the participants and just to not limit the number of participants that we might have. So that's the first reason, and the second reason is for those who use language as who use English as their second language, it may be problematic to translate those idioms. And now let's move to the Woke tool. So here I describe the features that it has. So it finds and it finds non-inclusive terms in your code, in file names, and in the content of files themselves. It also suggests alternatives that you may use, and it has some configuration that you can apply, for example, to identify the words that you want to mark as warnings, words that you want to mark as errors, and also you can choose what paths you want to search on. So yeah, here you can see the example of the GitHub action that exists there that enables you to run Woke on every PR in your GitHub repo to identify if this PR does not introduce any non-inclusive terms in it. So it's pretty simple. And here I have a slide demonstrating how this tool works. So it sees that there is a non-inclusive term in your code, and it has this pretty feature that prints the exact place where this occurs, and also prints the terms that you can use instead, if you wish. And in this case, this is marked not as an error, but as a warning. And as for the caveats that there is in this tool. So in my project, we needed to mark some words as errors to strictly fail on them, and some words as warnings. And currently, the tool fails both on warning and errors, and we needed to change this. So we made this change to the code and submitted this PR. But unfortunately, the second issue is that there is a lack of attention from the developer, from the initial developer of this tool. So hopefully, the developers will return and continue the work. But for now, we did the following thing. We created a clone kind of forked the project into our local repos, and yeah, and just created a custom action instead of the official one. And here how it looks. You can see that we are pointing also to our configuration file that we also customized for our needs. And yeah, instead of the official action, we're using just the path where we copied it to. And yeah, that's pretty much it from myself. And please, if you have any questions, yes, please.
Will it work without Git repo? I mean, on some directory or something? Is it possible to use this tool?
Sorry, could you repeat? I think I didn't catch it.
Kind of standalone tool, or this is some extension to Git repo? How it works?
Yeah, so you're probably asking about GitHub Actions. GitHub Actions is an environment that GitHub provides where you can use GitHub resources, virtual machines and containers to run any test on your repository. So you can configure it to automatically run anything on special triggers. So for example, in our case, we are running the stool on every PR to check the content.
But you can run Vogue without being in GitHub Actions, right?
Yeah, of course. Yeah, you can also run Vogue locally, and yeah, customize everything and just use it locally as well. Please just continue, and I will get to you.
Is there a plan to make the fork available if, say, the developer doesn't react in some time or something like that to the developers?
Yeah, actually, the fork it's pretty. We just.
Repeat the question always to directly.
Yeah, I'm repeating the question. So the question was if we can make the fork available to everyone, and the change that we did. It is currently publicly available in our GitHub, and it's actually pretty small, and it's not actually the full fork, but we just copied the code to our repo. So officially, it's not a fork. And yeah, so in the next slide, by the way, I have a reference section where I'm linking to this fork that we did, and also linking to some other things that I talked about today. Yes, thank you. Please.
I have just a question. When you mentioned that the woke action, actually the text includes words, but what if those words are part of documentation of specific tooling that cannot be changed? And is there like a way to tell woke to ignore this because there is this, but we cannot change it because of this tool? This is how it's provided.
Yeah. So to repeat the question for the audience, is it possible to ignore woke on some particular lines because sometimes, and this is the case with our project as well, we are working on many subsystems that just use the non-inclusive terms, and we cannot use them in our project because we're just automating what is there already. So first of all, in our configuration file, we marked some oftenly used terms as warnings, and did this change to not fail on them. And also, you can ignore separate files in the config file, or also in the file you can ignore a separate line by appending a comment above it or to the right of it to say woke. I think it's woke ignore and the name of the rule that you are ignoring. So yeah, it is supported. Yes, please.
So on a similar token, in some cases, the word that might be unwelcome in terms of inclusivity is key for the functionality of the code, right? And I'm guessing that remains to be just handpicked manually by whoever uses the tool. It shouldn't be changed like a copy and replace, right? So you need to check every instance like that. And is there any possible way around that, or is that just how it will be?
Well, yeah, that's the work. Yeah, the question is about that sometimes, again, you have terms that you cannot change because they are part of some other underlying project that you don't have like authority to interrupt, and what are the ways around it. And yeah, so in our case, we needed to do this work and to just run woke on every repository that we do support, and we like about 20 of them. And of course, some of the terms could be replaced because we are using them only in the repo, and some of the terms come from the underlying project. Some, for example, the name of the main database is master database in Microsoft SQL Server, and Microsoft, I doubt that they are going to change it in foreseeable future. So yeah, that's something that we need to live with, and yeah, in this case we just need to ignore this word either in the config file or on the line itself. Any more questions, please? Okay, if not, thanks a lot for your attention. Again, I think you will get the link to the slides, and the slides I have the reference section where you can click through the things I talked about and have some look at them. Thanks a lot.
to zaplý? Tak to budeme zkoušet, já můžu zavřít dveře. Jedna, dva, ne? Jo, v pohodě, v pohodě.
Okay, another lightning talk. We have Katka here, and the topic will be
manager swap. Hello everyone, my name is Katka. I am a manager of customer service team in EMEA, working at Red Hat. And I would like to talk to you about manager swap, about my experience. What did the swap, you might be thinking? Is it something like a wife swap or, well, kind of similar, but I guess with a different purpose, more noble one. The manager swap is a disruptive idea to blur the boundaries between regions and teams, and it kind of enhances our Red Hat open and inclusive culture. So the customer service department especially is presenting our culture to the outside world. So managers of this very team were the obvious choice when choosing the first people to try the first round of the swap. So our team used to be a small local team only taking care of regional customers, but then we became global. And not only that we had to collaborate with our US and Indian and APAC colleagues, teams, but also we had to work from one big backlog of customer requests, aka global queue. So you can imagine being global, it requires lots of consistency. And suddenly there was a lot to learn. So it was me and my colleague Ashley in US serving as guinea pigs for this first swap. And I got out of my comfort zone when I became a newbie in the US team. And I definitely started seeing things from different perspective. So the original goal that we agreed on was that we will basically attend each other's team meetings. We will have one-on-ones with all the team members weekly. And also the underlying goal was to identify some opportunities, maybe for better collaboration, and also how to improve our processes. In the first week of the swap, I immediately saw that the dynamics of my newly adopted team was a bit different. I detected some really crucial differences between EMEA and US cultures. See, the European way of communication is definitely more direct. Slightly blunt, maybe even harsh, you might say. We don't really do small talk much. We really prefer to address the elephant in the room, and this was a challenge for me. At the beginning, I was really trying hard, to fill the diplomatic mold, and I was getting lost in long sentences and in complex phrases, and as a result I always forgot to smile as well. That's strike two, that's another problem. You have to smile when you're speaking to American. If you don't smile, you might come across as impolite even, or rude. So we don't really dance about uncomfortable truths, and let's say the sugarcoating is not our forte either. So what to do? I am just wondering now, imagine how much time you would have if everything was addressed directly. I mean, you would say, this meeting is meaningless and we are wasting everyone's time. Instead, we have to say, I would suggest we postpone this meeting until we have further details and some structured agenda to cover. So Yeah, I don't know about you, but I always prefer the direct way of communication. Back to my newly adopted team. So first week we got to know each other. We kind of established our communication ways, and we shared our life stories. We shared the career journey as well. It was great. It was all virtual, obviously, but I got to travel to Panama, Argentina, Brazil, Portugal, Venezuela, all in my imagination. So it was great. They were all smiley and polite, but still I felt we were still kind of shy to each other. There was still some kind of boundary. And it was as late as the second half of the swap when I finally felt people are starting opening up to me. They started sharing actually their actual ideas and opinions. And this constructive feedback, that was the real gift. And me, by stepping back and simply listening to all that, I realized some practical implications as well. So for example, as we became a global team, and we wanted to be globally aligned, I realized we have to have some globally aligned new hire training as well. Before, we were 4 teams onboarding people our ways in 4 regions. So that was one big eureka moment or aha moment for me. And we should also not concentrate on processes that much, but also on the inclusive culture in that, during that new hire training. Secondly, I realized we need to encourage more interactions between the regions. So after the year since the swap happened, I can tell a lot of things have changed for the better. We do have consistent and globally aligned new hire training now. We have established stronger collaboration. We meet also not only with work-related topics, but we have some regular virtual games and virtual meetings. For example, we had some cooking shows where we got to learn how to make an authentic Italian tiramisu, or our colleague from US was showing us how to bake fantastic banana bread. So I honestly believe anyone on the team could benefit from a swap, not just people managers, but it could be easily individual contributor as well. So if you feel that you know better than your colleague across the ocean, you might be a perfect candidate for the swap. Because there is nothing better than trying that and walking in someone else's shoes to see their perspective and to understand their ways. I promise it's an eye-opening experience. Thank you. And now we can open it for the questions.
Sure, we still have 5 minutes, so if anyone has any questions.
Yeah. Or experience. Yeah.
Just a quick one. You talk about like international swaps, but what about interdepartmental ones? Even if the managers are doing quite different tasks, they can still apply?
Definitely. Oh yeah, sure. So I was talking about international swaps from the same type of team, but the question is if it can be applied when the managers are not managing the same teams.
Like development versus
development versus production. I believe there will be some value that you can find there, because if you are struggling with some other team, some collaboration is not as smooth as you would wish, it's definitely great to find out, to try to be in their shoes for a certain time. So, yeah. Yes?
How long was the swap?
1 month, yeah. So.
Was it a good time, or is it too short, too long?
It felt too short for me because, as I said, they started opening up only in the 3rd and 4th 101, which was like end of the swap. Before it was interesting, but it was all kind of polite and very, not formal. how to say that? Yeah, I feel like it got, we were getting to the interesting stuff only too late. Yeah. You need to build a trust.
I can ask more?
Sure.
Was there any effect like on performance of the team? Like I would think that like the manager change might affect things for a short period of time, or because it was a similar type of team, it did not. Or any thoughts on that?
The numbers were pretty much the same, but the effect is like my team is still contacting the other manager because they know each other, so the collaboration is more efficient and smoother this way. So, but in terms of how many requests did we do or something, no, it did not have any effect.
But surely there's a learning curve, right, for the new manager who comes to the team?
Yeah, absolutely. I highly recommend it. It's uncomfortable but great. Yeah.
And so it's like a one-to-one swap, like
yeah, this was one-to-one swap. Yeah.
Rather than just like being there with them at the same time during the periods, and then they come and visit you for the same period.
That's another version. Like, yeah, there is no how to say. Yeah, it can be freestyle. Yeah, Milan.
Did the other manager have a similar experience, or did you have completely different experiences that you then have?
Yeah, so we actually wrote a blog about it. So because I know you're from Red Hat, you will be able to read the blog. Of course, she loved it as well, and everything was shining and bright.
How about non-managerial swap, engineering swap?
As I said, I think it's a great experience for everyone. I'm encouraging now our team leads, our SOLs, like other functions, because I think it brings value. As long as you work for a global team, I'm sure there are some differences between the regions that could be understood better. So go for it. Yes?
Experiences dealing with any performance issues or such, and I think 1 month is like...
Yeah, 1 month is too short for this, and also just to explain, we did not have access to the HR stuff, so we were just kind of not on the surface, but we would not be able to, go deeper to the other team's data. So it was this way. It was just our agreement and an experiment. Yeah.
What is the brief summary of the other managers' point of view?
Well, I think Ashley was focused more on the personal side. So I was the one who was always trying to talk about work. I think Ashley was just relaxed, and they talked more. They were focusing on getting to know each other as humans more. But yeah, it was overall positive when you.
And specifically about the direct or.
Yeah, she did not mention any of this. Yeah, maybe it's an elephant in the room. Yeah, let's see.
Was there any insight or practice that you brought back to your team? Anything positive?
Yeah, one thing I totally admired how well they can connect. Like how they had really great team building ideas. For example, they have game night every Friday after work. They do some Pictionary, which is a game where you draw something and the others are guessing. And it's a simple thing, but we never did such fun things before. So we learned, we adopted this, and now we are actually doing the Pictionary with them together. So we have one joint team building with the American team. It's really nice. Yeah.
So unfortunately, we're out of time.
Thank you.
I'm sure that I will be happy to discuss
Absolutely.
anything else with you later. Thank you.
Yeah, thank you. Sorry.
Okay.
Yeah.
Okay.
Yeah, that sounds great. Let's probably wait another minute. I'm gonna close the door.
Yeah.
All right, we have another lightning talk. We have Sylvian here with the topic, what's new in the world, HTTP cache world. Yes, go on.
Okay, thank you for coming. For the next 15 minutes, we will talk about the new features and the past and the present also of the HTTP cache. First, I will introduce myself. I'm a French baguette, so I have a bad accent in English. I'm the creator of the Swan HTTP cache, that's an HTTP cache written in Go. And I'm also the maintainer of the Caddy cache handler. And I'm an active open source contributor. You can find me on GitHub searching Darkweek and Darkweek Dev on Twitter. So you can ask questions during the conference, but this talk is really small, so you can ask after outside. I want to say the tech is political, so if you want to fight some government's directives or something else, you can do that at your point. And also, I manage some students, so if you want some coaching or anything else in Go, React, or PHP, just send me an email and we'll see that. So go back in the past. There was too many providers that bring us some internet features. And we had the HTTP 1.0, but this version was the first stable version of the HTTP protocol, but there was a lack of description and a lack of customization. Some providers like Google or Akamai tried to implement on their own ways new features, but each provider implemented it on their own ways. So the behavior could be different from Google to Akamai. And support all providers was impossible. In June 1999, Matrix was available at the cinema, and they released the RFC 2616, also called HTTP 1.1. So an RFC is a Bayet blog, long, like 60 pages, and it's a fully technical Bayet blog. And this RFC introduced some grammar about the HTTP request response, what is a request body, how to define it more specifically and precisely in this description. It introduced some HTTP headers that we are using today, like the content encoding or content type, the range, and many other headers that are still in the HTTP protocol today. But in this RFC, we have the first part of the stable caching in HTTP, and it starts with the following sentence. Caching would be useless if it didn't significantly improve performance. So in the past, it was true. The cache was only for performance, but today we have some ecological goals, and if your cache consumes 10 or 20 times more than your upstream, maybe you don't need your caching system. And as it was the first release of the HTTP caching system, there was some bad sentences like this one. If a stored response is not fresh enough, so it couldn't be served to your client, the cache may still return the response to the client. So it's not good, because if your client don't want a cached response, you have to respect his choice. And you can see there is a warning header here. So you can still use it. Nobody uses it today, but it exists. It introduced some cache control directive. So the well-known no cache and no store. No cache don't say don't serve the cache. But okay, if you find a request or a response with the no cache, you have to revalidate with the server. A revalidation is like a normal request, but on your upstream, if the content didn't change, you have to return a not modified status code in your response. No store will say, okay, the return response mustn't be stored in your cache. The maxage directive will say, I accept the response and consider it as fresh for if it has been stored for X seconds. So if you say maxage equal 5, you can't serve a cached response that has been cached for more than 5 seconds. And no transform ensure that your proxy will not modify your request or your response. It can't add any headers and cannot edit the content. The directive only for request, you have the max tail to say, okay, you can serve me a stale response for X seconds. It's like it's the same as maxage, but for the stale format. The min fresh, so it's not used in production because it say, okay, if your response is stored for since X seconds, you can serve me and contact the upstream otherwise. And the only if cached say, okay, if you have a cached response, you can send me that. In the response context, we have the public that say your response can be stored in any cache system, private and shared cache. Private should be stored only on your browser cache because it's a private cache, or your proxy should implement the private cache system. The must revalidate will try to revalidate each time you serve this response to the server to check if it's fresh enough and if the content suits to the expectations. The proxy revalidate will trigger revalidation only on your proxy and not on your browser, for example. And the S maxage is like the maxage, but for shared cache. We have some extensions to extend these directives, and it's like a key value to implement some custom logic in your cache systems. So here with the community key, we define the value UCI, and you can say, okay, if the value is UCI for this key, I will store for 10 seconds and 5 seconds otherwise. In August 2001, Google Image was released, and we discovered the ESI language. The ESI language comes with the ESI tags, who already wrote some HTML in its job, or nobody? Okay, so okay, I won't explain what is HTML. So here you return a web article, and you have the full page that would be cached in your Varnish server, for example, but you have a dynamic header with the user.php call. Your client will say, okay, send me article.html. It will request on the web server the whole article. It will parse the HTML content and detect an ESI tag and make another request to user.php, get the response, and will replace the ESI block in your full page by the user.php response. Here is an example with the ESI include. We have some different kind of tags. The include will define the source and the alt. If the source fails, it will try the alt, and on error, you can say fail, and it will stop the render of the page. If it's on continue, it will just omit that and replace by a blank character. We have some try-catch blocks. And we can interpolate some variables. Here I will get from the cookies the type and logo name, and it will replace from these values to give me this HTML tag at the end. So here is an example for what could be your page with some different ESI tags, and customize the TTL for each ESI tags blocks. In 2014, the RFC 7234 defines the wall caching, provide us a new HTTP header called edge that can be negative. And it defines the invalidation, because the GET request can be cached, but if you send a put delete or a post request on the same resource, you have to invalidate now the GET resource in cache. The stale while revalidate is a new directive to say, okay, you can send me stale content, but you have to revalidate asynchronously with your upstream server. HTTP2, better performances, that's good. You have to enable that on your server. Some diagrams to illustrate how it works and why it is faster, thanks to the multiplexing. And everything is in the same pipe, despite the HTTP1. In 2022, they released two new RFCs, the cache status and the targeted cache control. The RFC cache status defines some directive to say, okay, my cache status hits some cache response, or forward because of the of why it has been forwarded. Here, the first will hit, and the TTL will say it will be freshed for 3 seconds. The second one is an URI miss, so it didn't find the URI in the cache, and the upstream returned a not modified status code. And the third is also an URI miss, because I have a detailed directive to say my storage was unreachable. The targeted cache control, your upstream will return some new cache control prefixed by a name. So we have the CDN, Varnish, and Caddy, and all your services will interpret and focus on this HTTP header to manage their cache. So Caddy will handle only Caddy cache control, and it will store for 1 hour. Varnish for 5 minutes, and the CDN for 2 minutes. And it will fall back on the cache control if none other match. And the client will store for no store, because it will revalidate each time he's doing its request. And what? Oh, no images. What about the future? Probably in June, because all the RFC are released in June. The surrogate keys. The surrogate keys will allow you to group your cache keys and invalidate them by a global key name. First group, second group, and third group. Yeah, no images too. There was so much implementation with Cloudflare, Akamai, etc. And I think I don't have the images. There was a QR code to a new RFC that is currently written, but you won't have it. And the resources, obviously no images. You have the and that's beautiful with that. But we have the GIF at the end.
So unfortunately, the schedule is very tight. So if you have any questions, I'm sure Sylvian will be happy to answer them personally.
Yes, with images too, also.
Thank you.
Thank
you. I'm going to take the mic from you. Mute. Thanks.
Yeah.
Here, you have 15 minutes.
All
if you
right.
have some questions, that's all right, of course. And we're gonna show you some time, like 10 minutes, 5 minutes, and then.
All right.
Right? We still have a minute, so.
Okay.
You want some water?
It's fine, thanks. Okay, ready to go? Okay, and then come in, close the door, take a seat. There's some still in the first row.
Great, it's time.
Okay.
That's it. Okay, so we have Thomas as our next speaker, and the topic is what's new in Chrome 1. Go ahead.
Yeah. Hi, welcome to my talk. My name is Thomas Huth. I'm working for Red Hat, and I hope you basically all know what QEMU is about. So who used QEMU before? Just raise your hand. Okay, who's just here because you were too lazy to leave? Okay, at least two. That's great. Okay, so QEMU is basically an emulator. It emulates 21 different CPU architectures and has support for a couple of CPU virtualization frameworks like KVM, Hypervisor Framework on macOS, and some others. QEMU does 3 releases a year, and the major version is bumped at the beginning of each year, so QEMU is not doing any semantic versioning or something like that. And this talk will cover the last year, so that means I will talk about QEMU 7.1, 7.2, and 8.0. If you're interested, the schedules are available in the wiki, so if you're curious when the next version will be released, just have a look at this URL that I listed here. The next release will be QEMU version 1. So let's jump into it. What's new in QEMU 7.1? So I have to say QEMU is a huge project. So each release contains a lot of new features, a lot of new stuff. And of course I cannot mention everything in a 10 or 15 minutes talk. So I had to pick some few, but that doesn't mean that the other features are less important. One of the big things that have been added in QEMU 7.1 is the so-called long arc 64 support. The long arc 64 is a new RISC CPU by the Longxin technology company. It's a Chinese company, and it's said to be a little bit a mixture of RISC-V and MIPS. And QEMU now supports both full system emulation with the QEMU system long arc 64 command. It emulates a para-virtualized machine there. And you can also run the Linux binaries for this architecture directly on a Linux host, for example, on your x86 Linux host with the user mode binary emulator. That's the QEMU-long arc 64 command. I also got a quick example, but I'd like to do it at the end, depending on how much time we will have left. Another great cool new feature in QEMU 7.1 is the zero copy send migration feature. And this allows you, when you migrate a guest in QEMU from one QEMU instance to the other, QEMU normally has to copy the guest pages before sending them over. And with this feature, you can skip this copy step. So it reduces the CPU usage on the host quite a bit. Disadvantage is it needs support for locked memory on the host, so it only works with Linux. And if you want to use it, you can use this. Oh, where's my mouse? This HMP is for Human Monitor Protocol, so this is the built-in shell, you could say, of QEMU. You can use it with this migrate set capability, zero copy send on command. Or if you're using libert, you'd say versh migrate and then -- zero copy to it.
Now, QEMU does not only add stuff. We are also removing some older features, since at one point in time the code base would become unmaintainable otherwise. And one of the older things that were in QEMU since quite a while already is the -sound HV command line option. This was used to configure the sound hardware in the guest, but it was considered legacy. It didn't have the possibility to connect it to a backend on the host, for example. So it's now advised to use the -device and -audio dev command line options, or if you want to do it in short, there's a new -audio command line option where you can do both now in one command. So if you were using -sound HV SB16, for example, in the past to configure a Sound Blaster 16 device in your guest, you would now do -audio and then PA for pulse audio on the host side, so that's the host backend, then comma model equals SB16, and this will configure Sound Blaster 16 in the guest. So this one command now wires up the guest side and the host side. QEMU 7.2. So QEMU has a bunch of network backends that allow you to send the network traffic from the guest to another place. And it had the possibility to tunnel the network traffic from the guest via a socket since quite a while already. But this only supported internet sockets, and a couple of people were asking about the possibility to use Unix sockets too. So QEMU 7.2 introduced two new network backends. There's native stream for connection-based protocols, and you would say now -native stream, and then you say address type is a Unix socket now, and you can configure the path. On the client side, so the other QEMU that you want to connect to it, you do basically the same, just say server equals off. And you can also use datagram-based protocols, like in the example here below, depending on what you prefer. Another thing that has been changed in 7.2 is that user mode emulation binaries for x86, they now default to different CPU types. So a couple of Linux distros recently switched to a higher level of the x86 architecture, you could say. So this is the x86 64 version 2 level, which require, so these binaries, for example, require some SSE extensions or stuff like that, which might not be available in older CPU models. And so that you are able to run these binaries out of the box, QEMU now defaults here to the maximum CPU model, so that gives you all the features that QEMU supports. And again, cleanups. In 7.2, we removed the so-called slurp submodule from the repository. This doesn't mean we removed the feature, it just means we removed the code. So for historical reasons, QEMU shipped the slurp code in its own repository and in the tarbals. But in recent years, all Linux and other distributions brought up and supply this slurp code as a proper packaged library. So takeaway here is please install libslurpdevil before you compile newer QEMU versions if you still want to use the -netdev user for configuring your network backend. Or there's another new alternative called past, which you can use also instead. This is an external program, so you basically connect a -netdev socket to that program, and it will take care of handling the network packages. By the way, there's a talk about Pasta, so that's the sister project of Past tomorrow. If you're interested in that, be sure not to miss it. QEMU 8.0, so there were many improvements again. I just wanted to list a few. RISC-V gained support for ACPI. On x86, you can now pass a random seed to the Linux kernel when you load the kernel with the -kernel command of QEMU. We've got now support for compact flash card emulation, and there have been quite a bit of performance improvements in TCG. So that's the tiny code generator, the JIT engine of QEMU. The backend now there supports a couple of CPU extensions if they are available. And as always, we did also some cleanups here, and this time we removed the virtualofs daemon from the repository. Since there's now a new implementation that has been rewritten in Rust, and it has become quite mature in the last month, so the decision has been made to remove the old implementation that was written in plain C. Okay, I think I was fast enough. So before we go to the questions, I can show you the example. So this is my normal laptop. Oh, wait, this is useless. This is my normal laptop here, so you can see it's x86 machine. And I cannot remember the options. So if I want to emulate this new system now, I download a kernel. So I mentioned in the slides where to get the kernel, the init.rd, and the firmware for that. You can start it like this. It runs through the firmware. It boots a system, so it just drops into the init.rd shell here. And if I now, can you see it? I hope so. Great. And as you can see, I've got now an emulated long arc system here. Works.
Full software.
Yeah, full software emulation, of course. Okay, and that's pretty all from my side. So let me go back to the slides. Questions? Yes, please.
The new support for using Unix sockets as a way for establishing network connections between multiple QEMUs. Is there also like some multiplexing server put in the middle so that the actual machines are connected?
I haven't looked at the socket implementation. I know that. Oh, the question was whether there's when using this new socket implementation for the backends, whether there's a kind of multiplexing server in between when you can connect 3 or more. I guess.
Yeah, so that the server is not running a VM itself, but it's just routing between the VMs.
I'm not aware of a multiplexing server in between or something like that. I know that at least the internet sockets are able to do multicast, so you could multicast to multiple QEMUs. I haven't looked that up in the new implementation, but I guess they would be able to do that too, hopefully. So yeah, the answer is multicast. Any other questions?
Last 3 minutes. If anyone wants to ask any other question, go ahead.
Okay. Then thanks for your attention.
Thank you. another lightning talk. We have Lukáš Zapatal here, and he will be talking about Anaconda with superpower.
That's right. All right, so here I am with my little pet project. I was working on recent hackathons, and I'd like to share the news and hear maybe opinions. Catch me on the Foreman booth if you like to talk about it more. We have only 15 minutes. So why I'm doing that is, the reason for that is that I think Fedora don't have a good image-based provisioning unattended story. Now with the cloud, everyone is now doing image-based provisioning, right? This is the right way to do it in the cloud mostly. And even other distributions like Ubuntu, if you install Ubuntu today, it is actually image-based installation and there's cloud in it. Also, there are other tools like Canonical Metal as a Service that actually does image-based provisioning for bare metal. And I spent a decade working with Foreman and Satellite, maintaining its provisioning capabilities. And these two solutions, MAS and Satellite, are common in a way that they are pretty tough to install. They really want to control all infrastructure. They want to control DHCP server, TFTP server, and if you can live with that, that's great. It works well. If you can't afford it, maybe you already have a DHCP server or other infrastructure. Doesn't really work that way. So then you're, fighting against it. So I was thinking like maybe can there be a little service that could provide you bare metal image-based provisioning? Because there's a common secret that Anaconda can actually do image-based provisioning, and this feature has been added in, I think, 7.2 Enterprise Linux, and it's been meant for virtualization, like overt, but these days it's still used for OS3 installations, and you can actually use this for normal Fedora or RHEL installations. So I was thinking like maybe I could write a project, small little service that you just run, and it will provide opinionated provisioning for image-based provisioning. It's important, so you first need to have an image, and then you can deploy it. Based around Anaconda, so it is built for Anaconda. It will not work for other distributions at the moment because it uses some unique features, and it's also based that it only supports EFI HTTP boot, which is basically like a simplified or more modern version of PXE booting. You don't need to have a TFTP server. You don't need to have a really complex setup. It's much easier. It's just HTTP or HTTPS. And of course, secure boot and HTTPS and DHCP v6 maybe, these are all the features that customers really ask, right? So I was thinking like, can I do that? And here I am with my project I want to share with you. So first of all, if you want to do any kind of image-based provisioning, you need to build an image, right? Couple of options. You can use Live Media Creator, which is in Fedora. It is, I think, not in RHEL. Or second option, I would recommend this one, is to use Composer. OS Build Composer is a component, program, a daemon that you can install on Fedora or RHEL, and maybe other distributions, I don't know. And it is a command line client, so you can use it to actually build what's called blueprint. Basically, it's like which packages to build, what the users you want to create, and stage keys and stuff like that, and then you create an image. Third option is if you go to console@red.com, if you have an account, you can even use free account, build images there. Now this service, it is basically a Go application, very small. It's called Forester Controller. That is the service that you need to run. You only need to give it a configuration in a sense that you need to point it to a directory where it will store images. That's basically it. It also needs Postgres and 3 tables, so it's not really big. And there's a CLI, and that's all you have. So you just build it. It's not in Fedora or anything like that. It's a prototype. I have a GitHub. I'll share it with you. And then the thing you need to do on your infrastructure is to set your DHCP server in a way that you just want to point it to this service, right? So in my case, it's running on port 8000, and you need to go and give it the /boot/EMFI. And that's all you need to do. It's like literally three lines for libvirt. For testing, you can actually use libvirt because that won't, conflict with you can continue using the default network. And for ISE DHCP, you would do the similar configuration. Now the workflow is a little bit different from what you maybe know from Foreman. I call it a la carte menu, and if you're familiar with Beaker, it's actually very similar. You first register an appliance. So in this workflow, EFI really don't work well with fallback mechanisms of BIOS, where you boot from network and if it doesn't boot, then boot from hard drive. That doesn't really work in EFI. So this service actually provides out-of-band management capabilities, meaning it needs to be able to power on a server and power it off and change boot order. So for this, I'm planning to add Redfish API, right? And also maybe IPMI in the future. For now, the project only supports libvirt. That is meant for testing. It's not meant for that you would like to install images using booting from network. That's really not the way to work. So first thing, you need to register appliance. In this case, libvirt, that is only supported appliance right now. And then you do enlisting operation, which terminology is a little bit vague. I'm not still trying to find it. This is borrowed from Ubuntu MAS, but basically it will go and search all your, let me say, blades within your chassis, or in this case, libvirt VMs, and it will store in the inventory, in the database, some information about them, specifically UUID, so you can actually power them on and off. And then you can power them on using the API of the service, and it will boot into Anaconda. And Anaconda will, because these systems are not yet set or configured to be installed, it will actually do what I call discovery. It will basically try to run a DMID code and find an amount of CPUs and memory, stuff like that. It will report these facts back to the service, right? That's exactly what Beaker does, except Beaker actually installs the system. This one is basically Anaconda, and then it shuts down. And once you're ready, or before you can be ready, you need to upload an image. So you have an ISO image that you've previously built or downloaded from our portal, or created in OS Build Composer. You upload it to the service, and the service, oh my God, hopefully this works. And the service will actually extract some files, key files like shim, bootloader, grub, Anaconda, and the image itself. And then finally you're ready to acquire the system. Again, terminology is acquiring means like you take it from your list of inventory of available machines, and you just want to put this particular image onto this system, and that's it. If you're ready to release the system back to the pool, you just call it release. And this is basically the operation workflow. As I've said, I'm using some unique features of Anaconda, specifically live EMG or pre-script and HTTP headers, but this is like not important. This is my Fedora cockpit, and I'm running terminal here. This is how it looks like, the service. You just call a CLI. It has 3 commands: image, system, and appliance. So first step, I have an image here called test1, and the important thing is it is UEFI image. It needs to be, UEFI VM, because UEFI HTTP boot is a special thing. It doesn't work on BIOS, because BIOS PXE doesn't have like a full HTTP stack. It only has like UDP, very simple protocol. So you need to have an EFI. So the idea here is you have a bunch of servers, and you have a, let's say, IPMI or Redfish API management. So you can actually like do the same workflow with these. Right? If you want to build an image in the cloud redhat.com portal, this is how it looks like. Make sure to check bare metal here, ISO, that is the type of the image you want to build. Or you use Image Builder. Image Builder has a nice user interface. This is my home server. You can actually install OS Build Cockpit plugin, I think, and it allows you to like do all the customizations, like put the SSH keys there and first boot scripts and things like that. So that's great. So once I have an image, I upload it here. So this line, image upload, you give it a name and then the ISO, right? And then I list all the images. So in this case, there's only one image called the rel9. Now I'm ready to define appliance. This is basically like a machine or chassis with multiple blades. In this case, again, this project is a really early prototype, so it only supports libvirt as like a testing machine, right? And so I give it a name, and it only supports Unix local connection, right? Now I can do enlisting operation. Enlisting does is actually it connects to the appliance and lists all the in this case VMs. These are not blades. I'm giving it a regular expression. I want only to use everything that starts with test, because I have multiple VMs there that I don't want to mess up. And I have a list of systems. So every system has an important thing is MAC address or multiple MAC addresses. It's a list. Every system has a like generated name, PAN cockpuk or whatever this is. It's just a random name, so you can use it. And then the most important thing is UID, so it actually can do a power operation. Now I'm going to reset it. Reset basically means boot from network, like connect to the appliance and boot it from network. And now you'll see, the system is booting up on the network. We'll try Pixie first and then falls back to the HTTP boot over IPv4. Anaconda boots up. And in the background, you can't see it, but it will execute a Python script that will just collect some data about the system, very similar to Beaker. And in the future, you could maybe search for systems that have more than 100 gigs of memory or some stuff like that. It's not implemented yet. And then it powers it off. But now, if I show the PEM system again, I see a bunch of new facts. And in this phase, this system could actually do like CPU burn or memory testing, or after provisioning, it could actually wipe the drive. That's what Ubuntu MAS does. Nothing like that is implemented. And now the final and the most important thing is system acquire. You give it an image, rel 9 in my case, and I forgot to type in the name of the system, like MAC address or the name of the system. That would not work, but suppose that I've typed it in, Anaconda starts up, and it downloads actually live EMG tarball, which actually is your file system, prepares the drive, storage, copies the file over, prepares bootloader and stuff, and then it reboots and your system is installed. So that is it. That is my project called Forester. And going forward, so I'd like to hear your opinion. If you would, like me to continue work on this, and maybe I need to write documentation. Of course, until I implement Redfish, it's sort of like unusable. Why would you implement provisioning of images onto Liver like that? That's insane, right? You just upload the image into Liver and run it, of course. So that doesn't make sense, of course. So Redfish is the first one. Maybe Terraform plugin. There are some bare metal Terraform plugins these days, but these are really tied to like a specific vendor or specific environment. Here, this is like, if you want to install Red Hat or Fedora and you have like a DHCP server, you can just, and a system that has PMC operation like Redfish or IPMI, you can do that. And maybe Ansible module or some integration with console, or maybe alternative to Beaker. It could be interesting. So many options. I'm eager to hear from you if you like it or not. So now, we have 2 minutes for questions, and find me at the Foreman booth if you want to talk about it a little bit more. That is my project. Thank you. And here's the URL. If you want to test it, it's really easy to like just jump in and forester.org/forester on GitHub. Thank you. All right. Thank you very much. Thank you. Cheers.
You want to use this?
Yeah.
Yeah, okay. Let's just plug it in.
Yes, test, 1, 2, 3.
All right, welcome back. We have Christian with us here, and apparently Chorus is dead. Let's see.
Well, yeah, hello everybody. Obviously the title was clickbait, but I'm still glad you showed up. And there is some truth to it. And I'm gonna, well, it's really a case study of how software sometimes dies, sometimes is buried, sometimes is reborn, sometimes is resurrected, or just has a comeback or shows up in ways that you didn't expect. My name is Christian Glombeck. I'm a senior software engineer in OpenShift at Red Hat. I am on the OKD Streams team, and we maintain the OKD community releases, which is the community version of OpenShift. Yeah, and I actually started my
my journey into software engineering with almost CoreOS, with one of the predecessors to CoreOS, which was Atomic Host, and I'll get to that now. So really, the past of CoreOS, and I'm not going to give you a whole history lesson on CoreOS because I wasn't there for the CoreOS, Container Linux CoreOS time. That was the original CoreOS. It was a Gen 2 based system. It was then renamed to Container Linux, at least the community variant, and then Red Hat bought the company CoreOS, and we created a new operating system that took the name of the predecessor, but really it was a new operating system, and that operating system was based mostly on the Atomic project. Some folks may still remember the Fedora Atomic Host releases. I think there was also a Red Hat product in there somewhere. And really, we took the best of these both worlds, or at least we tried to do that. And I think we did pretty well in taking the best from to create the new current CoreOS. So really, what do we have today? What's happening in CoreOS land? The main Fedora CoreOS release, which is the upstream, leverages all kinds of software. It's built with RPM-OS tree, so it's image-based or hybrid image-based. You can rebase from one image, which is a digest in a repository, to another one. And that really, that changed how we deployed and provisioned the systems, and it really made things much easier for us. There's obviously things like Podman, which is our main container runtime. In Fedora CoreOS, we actually still ship Moby, which is Docker. And Ignition is our first boot provisioning tool, and we took that from the original Container Linux CoreOS. So that's a declarative way of configuring the machine you want to provision up front. You have a config file, and that essentially gets written to disk. It defines file contents, all kinds of things you want written to disk. That gets put in Ignition config, and then on the first boot, the Ignition binary writes it while it's still in the init RAM stage, and writes it to disk, and then reboots into that newly configured, pristine operating system the way you want it. Recently, we introduced something that really is a big leap in how you can work with CoreOS, which is CoreOS layering. And it's been mentioned a couple of times in other talks today, but really what it is, it enables the operating system like a container image, because the operating system is a container image. So you can import it with a from directive in a Docker file, and then RPM-OS tree install other things, other RPMs on top of the base, which could be Fedora CoreOS or RHEL CoreOS, or the newly introduced Stream CoreOS. And that really makes it easy to use the base that the community provides, the Fedora CoreOS or CentOS Stream CoreOS, and make your own version very specific to your needs. And a great example of that, how a community starts to appear around things like this, is Universal Blue, ublue.it, ublue.it. And they actually, it's a community project, and they actually use CoreOS layering to build derived images from the standard stock Fedora CoreOS. I think they put in NVIDIA drivers and things like, things that we can't ship in the Fedora repos. And they configure it for different use cases, gaming and workstation. They have a couple of images there. What we end up with, or what we currently have, are three main versions that we officially release and distribute of CoreOS, which is the upstream Fedora CoreOS, and then the downstream Red Hat Enterprise Linux CoreOS, RHEL CoreOS, RCOS. And we recently introduced a midstream distro, which is CentOS Stream CoreOS. So that's essentially for RHEL CoreOS. It's about 6 months ahead of what's going to get into RHEL. Meaning, the way this works is RPMOS3 builds images by consuming RPMs, and it creates an image out of these RPMs. So everything in the image is part of an RPM. And so for these three composers, three different composers, we use, for the CentOS Stream one, we use the CentOS Stream RPM YAM repos to pull RPMs from, for Fedora CoreOS, it's the Fedora repos, and for RHEL, it's the RHEL repos. But the manifests that define the RPM lists, the RPMs that you want to include, are actually the same, or mostly the same. For SCOS and RCOS, CentOS Stream CoreOS or Stream CoreOS is SCOS, Red Hat Enterprise Linux CoreOS is RCOS. They're actually exactly the same manifests. It's just a rebuild with a different set of packages, different versions of the packages with different sources. One comes from the CentOS community, the other from the Fedora community. And we're pretty happy with where we are right now. It's especially the layering and all the new goodies we've recently introduced. It really feels really nice to work with the stack, but we're not finished. And this is kind of where the next death is around the corner, right? Is it going to be, what's it going to be? What's going to go? What's going to come next? And that really is the only constant is change. And so, what's next? What do we want to do? What do you want to do? There's a lot of interesting projects in the realm that we kind of have our finger on the pulse, or are following, or definitely want to include. There's things like, can we make these layered images supportable? Actually, maybe do something like build one common base, and then have different layers that share the same common base, but that do different things. So you could imagine one derived image for the Kubernetes stack, one for workstations, and one for IoT devices, for example. They could all share the same, would be very easy to reproduce and to also change if you're unhappy and really want to derive. Again, you can derive from a derived image. It doesn't really matter, because in the end it's just shipped as a container image. And that container image you can use as a container image, but it's a bit special because it also includes a kernel. So when you run it as a container image, the kernel doesn't do anything. But when you use RPMOS3 to rebase to that image, then the image is actually written to disk, and the system is rebooted into that image. Then it's not in a container anymore. We really use the container as a distribution mechanism for the images, because container registry are ubiquitous today. So what are these things here? UKIs, Unified Kernel Images. That is something I'm really excited about. I think it'll make our operating system safer, because with that we'll be able to do attestation from the start to the end. Essentially, it'll be much easier than with the current bootloader stack that we have. Obviously, there are different interests here, different teams, different requirements from customers, from community users. So really, nothing is set in stone yet, and we don't even know how it's going to look when we get there. So really, this is the time to shape this. There's other things like boot C, which could replace RPMOS3 sometime, and yeah, really a lot of and Compose FS, which will enable FS Verity for our use case in RPMOS3 or even boot C based image distributions. And really, what's the takeaway? What do I want to say with all of this? And especially with the looking into the future, right? We can't change the past, but we definitely can do our best to shape the future. So really, what I want to say is be the change you want to see in a software project, and open a PR, right? That's like, yeah. The quote is not by Mahatma Gandhi. And that really closes the circle here back to this conference's motto, which is Define Future. you can define your own future and be part of it. And I'd like to invite you to do that and to join any of these projects here or any other. Join the community around it and contribute to open source. Thank you very much.
Any questions for Christian?
Yeah, well, with the move to container images, it seems like the original value of RPMS, especially inside the container, has greatly diminished. Like, is there still a future for that, or is it just like build a container in whichever way and then we deploy it as an image outside?
So, well, there is. Oh, yeah. The question is is RPM-OS tree within a container still valuable? Because you don't really need the package manager inside a container, I guess. And that is essentially where things like bootc comes in. That doesn't ship a package manager. In RPM-OS tree is both the server side that builds, that composes an image, but it's also the client-side package manager that installs more images. So it's kind of, there isn't a clear split in the code base. It's just one binary that does both. And with bootc, the build part would be separate. And bootc wouldn't know about RPMs. It would just know how to out an OS tree native container to disk and boot into it. And maybe upgrade to the next one. So yes, there is, like, maybe it doesn't make sense going forward. Maybe there are use cases where we want the layering to happen in a container build, because you can do these layered builds with Podman build, Docker build, on a cluster, anywhere. They don't need to be privileged, which is also different to the base compose needs to be privileged, because we need virtualization enabled in the builder and run some stuff in a nested nested virt way. And maybe that's going to be solved by bootc, some of that at least. So definitely there's a lot going on, and maybe in the future we won't even have a package manager on these immutable systems. Yeah.
Anyone else? Anything? Patrick, anything? No. That's it? All right.
Thank you.
No.
Alright, I can just press this.
Jestli nemáš bez Bčko, tak...
Yeah.
So let's do it. So we have another topic here. We have Ondra here. You may have seen him because he's got a booth here as well, right?
Exactly.
Of course. So, and the topic will be the clicks and quacks of the mechanical keyboard. Go.
Thank you. So, hey, my name is Andre. I'm a software developer at Red Hat, also a student right here at this very faculty. And I'm a huge keyboard nerd, as you might have noticed by now. As a disclaimer, I'm going to use the P word, so watch out. Preference. Everything in this hobby is about preference. You may not agree with all that I'm saying and all this stuff. You may like different things, and that's all right. You know, there might be more interesting flavors, but people still like vanilla, all this kind of stuff. As to why mechanical keyboards, let me start with this. How many of you guys do have a mechanical keyboard, by a show of hands? Okay. How many of these have Cherry MX switches? Quite a lot. All right. So, why mechanical keyboards? Well, options. More specifically, options in looks, because the keycaps are compatible between each other. You can mix and match all this kind of stuff. Options in feel, which depends both on the switches, because the switches have a different mechanism and stuff, and also cases, because there's cases designed to be more light on the touch and stuff, all this kind of weird stuff in this hobby. The sound, there are plenty of people just obsessed with the talk, as they call some kind of a sound and stuff. Options, layouts, plenty of layouts, and firmware, because most of the, I'd say more expensive as well, but especially the more open source split, weird kind of keyboards use open source QMK firmware, which is, you can set up anything you want. So, and yeah, open source, because some of the keyboards just are available anywhere. I mean, on GitHub or something, and you can just order the PCBs and build it yourself. Switches. I use this amazing graph with emojis combined with each other. This is for these little things I'm gonna pass. You can try and test this, see which switch you like as well. There's the cherry, the hole, because it's a rabbit hole once you go into the enthusiast switches. And then there's silent switches as well. And there's a linear one, the tactile ones, and the clicky ones. There's no clicky silent one. That's how you tell which way to orient this. So I'm gonna pass this along, and good luck. But yeah, to sort of help you with this, the main difference you should be basically looking for the linears is the non-cherry ones are usually more smooth, while the tactile ones have a stronger bump, and the clicky ones just use a different click mechanism, so it's not much of a rattle, it's more like a pure click. So, some common misconceptions for switches. There's a lot of saying like red is for gaming, blue is for typing, brown is for everything else, or for everyone. Most of these things are basically just some things to get you to actually buy some keyboard and figure it out by yourself. It's all about preference. I use reds or linears for typing and programming, all that stuff. It's not that it's gonna help you in any way, it's just preference. It all depends on which one you like, and since not everyone is able to just go to a store and try a bunch of switches or order like this switch tester. Then it's kind of difficult to help anyone because everyone has different taste. So then this sort of bullshit was made up to help you just figure out, go for it and buy a single switch. Then Cherry MX switches. There's this thing that there's this issue that Cherry had a patent until 2014, so there weren't any other brands making these switches in the same standard as nowadays there are. And so Cherry, instead of innovating on newer switches and more like smoother switches, better switches, they sort of just went with marketing that we're the original ones, we're the ones that everyone is copying, and German engineering, so it has to be the best, right? And it's sort of falling off slowly, but people still have this sort of mindset that the others are a clone that can't be good, right? And they're Chinese. But yeah, nowadays Gateron and other brands, most importantly, they innovate a lot and provide some better switches as well. Also, that mechanical means loud. This is a mechanical keyboard. I don't believe anyone from the backside can hear this. Never mind, I'm out. But yeah, there's this sort of, misconception that mechanical has to be loud, but there are specific silent switches which are even more silent than your usual membrane keyboard. And then the color coding, which is just something that works for the basic red, brown, blue, and other switches, but other brands don't really follow it once you get into the more enthusiast switches. So also then the options are in layouts. You might have seen your usual 100% keyboard. I'm gonna ask you to raise your hand and then lower it the moment I go too small for you guys with the layout, all right? So everyone raise your hand. All right. Does anyone need a 20%? Okay, so 96, that's just, okay, one hand, just the editing keys sort of squashed together with the numpad. A TKL, it's just the 10 keyless without the numpad. This is FRL, F-rowless, but watch out, this one also has a blocker instead of the Windows key, because some people think that's a very awkward place to have a key. So this one is a F-rowless, Win keyless, 10 keyless, actually. Then there's a 75%, which doesn't have the usual function keys at all, or the editing keys. 65%, which is without the function as well. That's quite a lot of people. Okay. Now we delve into the 60% without arrow keys. You have to use the function layers to sort of use other stuff. There's the Arisu and stuff for like slightly more ergonomic boards. The Ortho, which, okay, 3 more hands or something, okay. That guy has a split, that doesn't count. Then there's the splits. Usually what people end up with are smaller sizes because once you go for ergonomics, you also don't want to stretch your fingers as much. So you use layers to sort of do all kinds of weird stuff. And then also you can 3D print some cases. So you get stuff like this. Or this is what I use at work, basically.
It's like a skate park.
Yeah, it's like a skate park. And then you need a manual for your manual, basically, for the layout you're using in your keyboard. But don't tell me you don't use a 40%. You can't use a 40% if you use this, like, and you only use 2 fingers. Just come on. Now your thumbs can actually do something, and yeah, it's manageable. And it's not a joke. These are some kind of jokey layouts, but the 40% actually work. So there's plenty of memes to go around, but yeah. And that would be mostly it for me. Thank you. So, any questions? Preference, again. Have to.
How many keyboards do you have at home?
I think I'm at 8 right now. Oh yeah. I have well, how many keyboards do I have at home? I have about 8 keyboards, so I can have one for each day of the week, obviously. But yeah, you can sort of see the journey I went with, smaller, and.
Well, you could just have 2 keys, Morse code.
Exactly.
What is the best switch?
What's the best switch? Preference.
So, do you find often users which mix switches?
Mix switches, as in they have.
For example, the VS AD keys.
Okay. Some people use heavier springs on like the space bar and stuff, but that's not very common. I would say most people just go roll with full keyboard with a single switch in the community.
What do you think the best switch is?
What do I think the best switch is? Right, I'm a big linear kind of guy, so I would say like maybe Gator or Oil Kings are my favorite right now. By the way, from the people that tested the switch tester, I'm not sure how far it got. How many of you preferred the cherry ones? Okay, I think that answers a lot of your questions. What about cherry? There was a yeah.
How can you get a tactile effect in a foot switch?
In what switch?
Foot switch. As well as a keyboard. Can you make so to operate more keys with your feet?
Okay, like a clutch, Vim clutch.
It's really good for shift control and so on.
Okay, I've heard of the Vim clutch, that people use a Vim a clutch like for using your when driving to switch modes between Vim and stuff, but I have no clue how those work. So
Do you know how to drive? Oh, I use Vim.
I can't use. I'm not a driver, so but I can use Vim. All right, if you guys have any, okay.
Maybe last question. When you switch from keyboard to keyboard, like how much time do you need to adjust a new layout? Or
As long as the boards are different enough, my brain just clicks. It works immediately. But as long if the layout is sort of similar, like if I've switch between the split and a normal keyboard, it just works automatically. But yeah, if there's like I have an ortholinear as well, and that sort of messes with my brain because it's similar to a normal keyboard and a split as well, sort of, and yeah, that doesn't work too much. But yeah.
I had a last team question.
Okay.
If you have the linear switches, what's the difference between a mechanical keyboard and the non-mechanical?
The non-mechanicals aren't usually linears. They're
Exactly. So that's why I'm asking for the linear switches.
Oh yeah, I should have been repeating the questions, right? Sorry. So again, the question was, what's the differences between linear and
Linear, non-mechanical, and linear mechanical.
Because
I always associated mechanical to not noisy.
yeah. Usually non-mechanical are not exactly linear. They're mostly membrane. Like membrane are actually more tactile-ish because you have to pierce through the sort of membrane bump. So they're more tactile-ish. So yeah, the difference is in the feel, but they're also mechanical overall just don't feel as mushy, which can happen with the silent ones because they're actually like some rubber inside the switch to actually make them silent, but they're still way off in feel compared to a normal switch, like membrane. I mean.
Do you have any experience with creating custom keycaps?
I have not tried. My girlfriend did some artisan keycaps, just like a little toast or something. Like you could do those, but I haven't tried like any 3D printed stuff. I did like a keychain stuff you can take at my booth, by the way. And yeah, all the other questions I could answer at the booth in E, all the way that way. So I think we're out of time.
We still have time.
Okay, never mind.
All right. Well, thank you. Mr. Mark, and the topic will be PyTest container.
Yeah.
It's yours.
Thanks for your numerous attendance, given the beautiful weather outside. I'm done, and I'm going to tell you a bit about testing container images with Python and PyTest. First, the boring part. So that's me. I work at SUSE. I kind of became the release engineer of our base container images. Besides that, I also do other stuff, but since we only have 15 minutes left, let's skip the boring part and go to the interesting part, and that's why on earth would you use Python and PyTest if you have shell scripts? And we all know shell scripts are portable. They run literally everywhere, even on your 20-year-old AIX machine. They are super fast. Exceptions and terms and conditions apply. And everyone understands them. And I'd like to use this small opportunity for a quick poll. Who of you likes shell scripts? Please raise your hand. Oh. Okay, that eliminates the next question. Never mind. My point has been served. So for the recording, there was like 5 people, and there's, I guess, 50 in here. So I think I don't need to convince anyone. So let me still give you the short sales pitch why you should use Python, PyTest, and especially the plugin that I wrote for testing container images. Because, well, shell scripts, in my opinion, they are pretty brittle. They usually tend to break, especially when you don't like it. Because, I mean, I don't understand shell quoting. And when I write shell scripts, I have to start writing tests for my shell scripts. And if I start writing tests for my tests, I'm doing it wrong. So let's not do that. So what can this plugin do for you? You can define all your container images. It will do all the pulling, all the building, launching, cleanup for you. So you don't have to do that. You can use the test infra module, which gives you just a very nice abstraction layer all around all the common file system operations, checking whether there's packages installed, essentially all the stuff that you also can do in a shell, but just in Python. We've been relatively meticulous about support of parallel test execution, so you can run all your tests in parallel, also if you expose ports, also if you do volume mounts, and so on. Because that's also, as I said, one of the features. It will find you free ports and actually tell you what the port is. So, I mean, you can just bind some random port via Podman and Docker and then have fun finding the JQ expression to find the correct port in the output of Podman inspect. PyTest container will do that for you. If you use Podman as the backend and not Docker, then you can also use pods to create them, to have a shared network. You can create and clean up container volumes and bind mounts if you need that for some reason. Also, if your container somehow declares a volume and creates anonymous volumes, they will also get removed afterwards, so you don't suddenly realize my container storage suddenly consumes 10 gigabytes. Where did that come from? And you can also use some fancy PyTest magic to just execute the same test on multiple container images. That's relatively useful for instance, for testing the same piece of software on multiple operating systems. And yeah, and it supports Docker and Podman. You can switch between the two by just setting an environment variable. So now with the sales hat off, next one, it actually runs on RHEL 7. I don't think that's a great feature because it also comes with all the catches, but it runs. And it also works on all the architecture. And let me tell you, PowerPC and S390X weren't fun, but it works. So let me give you just a very short example how this would look like in practice. You import all the stuff that you need. You define yourself a container. In this case, it's just the OpenSUSE Tumbleweed container. And then you write yourself a test, which does really nothing very impressive. It just checks whether the file @COS release exists. So this, what you see here is just the test infra module that handles that. And this parameterization is just included for PyTest container. Now, if you would write yourself put this into a Python file, install the required dependencies and execute PyTest, then the plugin will pull down the container image, launch the container before the test, connect to the container, check whether etcos release exists, and after the test has passed, it will just remove it and spin it down again. So what can you use this for? You can use system tests of your container images if you create operating system container images. You can test applications that you deliver via containers, because just because it's in a container doesn't mean it actually works. Or what I also think is a relatively nice thing, and where we use it in a few places, is that you run a few tests on multiple different operating systems. If you want to run it on Fedora, on OpenSUSE, on CentOS, whatever you like, you can do that. So for the record, the whole plugin uses a few features of PyTest, but I guess since there's so many of you, you probably know that this is a Python test framework and what it executes. It relies heavily on Python fixtures, which are just magic functions. These handle all the spinning down and the destruction of containers. And what also is relatively useful is that you can parameterize tests. In this case, your parameters are the containers. So, and now let me just breeze through various examples what you can actually do in practice. So common thing is you have a base container and now you want to actually build stuff in there. So in this case, you would define yourself a container file. You put that in this derived container class. You don't have to take pictures. The slides are on GitHub. So there will be a link at the end. Then you just pass it as a parameter. And in this case, it's just doing a very dumb check whether Python 3 is installed, because we just did that up here somewhere if the font rendering wasn't broken. Sorry about that. Another feature is binding free ports. That's especially nasty if you want to run tests in parallel, because if you try to bind the same port from two containers, oops, won't work. So in this case, you define yourself this, you pass just a parameter to this derived container class, and then inside your test function, you will get access to the port to which this port gets bound on the host. So then you can, for instance, just curl it and find out, does my container respond to this? Or if it's running some other service, you can use whatever means necessary to contact this host. You can create pods. This has, so as you see, I'm a very creative person when it comes to naming, hence this thing is also called PyTest container, and the pod class is called pod. Makes it kind of obvious, but as I said, not a creative name, and the pod just expects a set of containers. The main use case for creating pods is, at least so far as I've used it, to just expose some service to the outside. And so hence you can also forward ports from this pod, and you use it kind of in the same way that you just pass it as a parameter to your test, and then you can do whatever you want in your actual test. One thing that I have so far omitted is that all of these tests reuse the same containers, and they assume that you so as an optimization, they assume that your containers actually don't mutate things. So if you suddenly start RMing things, all your subsequent tests will be influenced by that, and you might not want to do that, but there's a workaround for that. Just use a different fixture, which is creatively called container per test. And then you can also do things like testing whether RM minus RF will actually work. I haven't run this one because I'm too scared, but maybe you're brave. And in theory, things like this should still work. You can also, if you have a set of tests which should all run on the same container image, and you don't want to write this PyTest mark parameterize for everyone, you can just define a global variable called container images and use a fixture called auto container, and then everything will just be automatically parameterized via some very nasty PyTest magic that I'm not proud of. If you try to build containers, then sometimes it also happens that containers depend on each other, and you can do that one as well. So you can define yourself a container, then build another one on top, build one on top. Please don't add circular dependencies because that will most certainly break. But then you've been warned. And once you execute the actual test, the plugin will first look for the container that's been requested, find out, okay, I need the other one, I need the base one, the tumbleweed one at the top, pull that one, build the subsequent one, and so on, launch your test, and after the test, destroy everything again. If you want to have some abstraction over podman inspect or docker inspect, there's also one for that. So you can just grab the inspect property from the fixture, and you'll get a bit of the output that podman inspect would give you. So for instance, config, cmd, but not everything because there's a lot of info and it's definitely not stable over releases, and I don't want to support all of that. You can create bind mounts. Again, this is very creatively called just bind mount, which can be occasionally useful if you want to bind a specific directory. What you can also do is to bind really specific container volumes. But you can also achieve that by just putting a volume instruction in a file. But in case you need something like that, you can make the plugin aware of that, and then you'll also get all the automatic destruction that it supports. One thing that I think is very useful is health check. Please use health checks. They are great because often your services actually need a bit of time to launch. And if you test your service yourself, you'll launch the container and it will take you a bit to type the test command. Python is faster. And usually you wonder, why does the test break? Then you check the running container and it's still working. And it's actually working, but your test is failing because your test executed far faster. So if your container contains a health check, then the plugin will automatically wait for your container to become healthy, and after it's healthy, it will start checking. If you don't want to do that, for instance, because you want to check whether your health check fails, then you can also configure that. You just tell it, don't wait for it, and then it will not bother you. As I said, you can use Docker or Podman. It will use Podman by default if it's installed. Otherwise, it will use Docker. You can just switch that via an environment variable. You can run tests in parallel by just installing pytest xdist and by whatever means you want, and then just pass the -auto flag. And really, that's also how we use it. So if you run heavy tests, you can murder your machine as much as you like, but it will run the tests in parallel and way faster. And also, the plugin really tries to clean up everything. So all launched containers get destroyed, all volumes get removed, all ports get removed afterwards, all temporary directories. What is retained are images and intermediate layers, just because then the tests would take ages to execute. There's a few things using it. For instance, the BCI test suite. A bunch of other services, as you see, all kind of tied to OpenSUSE because I made them use it. But maybe your project, or you tell me about your project and I'll make you use it. I would like to thank a few people, mostly Jean-Philippe, who made the initial prototype with myself. I'd like to ask you to give it a try if you find this useful. As I said, the plugin is on GitHub. The documentation is there. As usual, there's room for improvement, but I don't know where currently. The slides are linked at the bottom. And with that, I would thank you for your time and be happy to answer all your questions.
Okay, so now we have time for questions, so feel free to ask.
So, if you do xdist, does each, you mentioned that there's support for sharing containers. Does each xdist worker get its own copy of the shared container, or is it truly globally shared?
So what do you mean exactly by share?
You can get one container for each test, gets a separate newly created container.
Mm-hmm.
You said in the default mode it shares the container over multiple tests.
No, So if you use in the default mode, you will get the containers will be shared. To be frankly honest, I know this is embarrassing because I wrote it, but I'm not sure if it will. It might be that the containers that if two workers in parallel launch the same job, they will actually get different containers. But the sharing is an implementation detail. You shouldn't rely on that. It's meant to speed things up. So how that actually behaves will depend on the behavior of PyTest of xdist, how it actually handles that. So yeah, so the thing is, I'm not sure how xdist would handle this kind of fixture. So it's just a fixture that's global for the whole test suite. It should be a session scope fixture. Yeah, so then they will be different. Yeah.
Thank you. We run out of time, so we can probably HTTP. So thank you for your time.
Okay, thanks.
Coming again, we have another session here, and we have Mirek with us, and the topic will be open source fitness apps.
Hi everyone. Can you hear me okay, even in the back?
Yeah.
Great, awesome. So I'm here to talk to you for a bit about open source fitness apps, namely Vegger, Feel, and how we're creating an exercise wiki. Before I get into that, I'd first like to define what is actually a fitness app. Well, a fitness app, that's a broad term a broad category of apps that covers a wide range of physical activities for people with a wide range of expertise with varying demographics. But what brings all of these different apps together is they all help you improve your physical fitness. Unfortunately, what's also very common with these apps is that they're oftentimes proprietary, which means that you don't really have full control over your data or over your habits, over what's running on your computer or phone. And the problem with that is, let's walk through a scenario. Let's say you install this app, you build your habits, you use it to track your walking or cycling, running every day. You build up a lot of data, you track your progress, but then suddenly it is shut down. And then what do? Well, you have to find a different app. You have to completely change your habits because you can't really use the app that you've been used to anymore. You have to hope that the alternative allows you to import data from the app. You also have to hope that this app will let you export your data. So quite a change, but that's not the worst case scenario. It can also happen that your app can leak your data, which has happened in multiple cases. And there were real-life risks associated with that, also in multiple cases. So we'd like to change that. And by we, I mean me. I'm the author of Feel, and also Roland Geider, who was supposed to originally give this presentation with me but couldn't make it today. So we want to change this, and we want to make free and open source fitness apps the norm so that people wouldn't have to compromise on their privacy or the control over what they run on their device or their habits just to be fit. So this is our goal. Here's where we are now. We have these two apps that you can use right now. And there's also an API that anyone can use. It's a public API associated with Vegger. I'll go into more detail about each of these. So my app Feel is a simple guided workout app. Basically how it works is you open the app, you see a list of workouts, you choose a workout, and then this app guides you through that workout, telling you how many seconds you have left before the break and then before the next exercise. You can choose from some pre-made workouts, or you can create your own. And this app runs on Android as well as Linux. It's a Flutter app, so it's easy to port to other platforms, and all your data is stored locally. The problem with this app is that for now, there's only 57 exercises that you can build the workouts from. So while you do have images and descriptions, etc., for these exercises, there's not that many workouts that you can actually build. But this is going to change, and I'll get back to this. Then we have Vegger, which is an online application that allows you to create your own workout schedules, create your own meal plans, and then helps you follow up on them. You can track you can track all of these things via this web interface, and it's for more expert, more seasoned athletes. This is a web application, but you can host your own server, so you still have control, and of course it's all fully open source. And there's also client applications for Android as well as for Linux via FlatHub. There's also the Vega API, which Vega pulls its information from. And this API gives you access to all of the things that you store in Vega, including your account details, meal logs, nutrition plans, workout schedules, etc. But most importantly, it also hosts the exercise wiki, which is a very important aspect, not just for the users of Vega, but also for free and open source app developers, because suddenly it creates a centralized resource that developers can use to get exercise data, exercise images, exercise metadata, such as which muscles each exercise targets or what equipment you need to use for each exercise. And all of this is licensed under the Creative Commons share alike license. All of this is, just like with Wikipedia, contributed by a range of people. And really, it's an invaluable resource that one person couldn't create by themselves. The beauty of crowdsourcing is that everyone contributes a little bit, and then you build something huge that no one person could easily create. And we see this as really kind of a launchpad for various free and open source fitness apps that they can use, because suddenly it becomes much easier to create your own app for your own niche that you target to your demographics of choice. So we're building this. Vega right now has 350 exercises in its exercise wiki. There's more than 22,000 accounts on there. It also has more than 2,300 GitHub stars, so it's relatively popular among developers as well. The wiki is relatively new, and there's some bugs being sorted out, so this exercise number is sure to grow in the future. But we still haven't reached our goal of making free and open source fitness apps the norm. So how do we get there? Well, we need you. We need the community to contribute exercises, to help us build apps and more. There's a number of ways you can contribute. I've mentioned the wiki. You can go on vega.de today and contribute an exercise or contribute changes to an existing exercise that's on there. You could add more information. You can revise the steps if they're not correct or there's not enough information. You can upload images. I would hold off on uploading images for now unless you have public domain images that you can freely share, because there's, and this is still being worked on, there's missing functionality for specifying licensing. So unless you have public domain images, don't upload images yet, but maybe save them to a folder for uploading at a later date. Speaking of images, of photos, in my experience, a lot of people don't tend to like taking photos of themselves and publishing them online for people to use and see. And this is one of the reasons why Feel uses this low poly look, this triangulated look. And what you can do if you're feeling shy about submitting your own photos is download this app called Floss Triangulator. It's a Java app that you can use. It's on FlatHub, but you can also use it on other platforms, of course. And you can add your image, create a low poly version like this, which you can customize where the points are so that it looks good and so that it's anonymous enough to your liking. And then you can export the SVG and submit that so that your face is obscured enough. You don't have to feel shy, but you can still contribute to this this open source wiki of exercises that we have. And then besides these ways of contributing, there's also the standard ways you can develop. You can help with development of these two apps, or you can develop your own app, perhaps integrating some of or all of Vegr's API, including this exercise wiki. You can help us translate. You can translate via WebLate, or you can translate exercises via the Vegr wiki. You can help design, you can help test, and of course you can spread the word, share on any social media that you happen to use. So I hope you're as motivated about making the world of free and open source fitness apps happen. If you are, you can visit these links. There's also under these links, links to chat with the community, so you can talk to us there. And I think we have a little bit of time for questions. Yes?
Do you have support or maybe community integrations to like fitness devices like, Fitbits and, Android watches, that kind of thing?
Right, so this is, so the question was if we can integrate with hardware such as smartwatches, fitness trackers of all kinds. And this is maybe in the on the roadmap. Right now we're focusing on more core stuff, such as this wiki. But I'm sure that eventually there will be support. You can, if you'd like, you can help us implement this. And potentially, if there's more free open source apps, because there are some open source apps already that do have this integration, mostly on F-Droid, perhaps we could collaborate with them as well. Yes?
I would like to ask more details about your plan to make this norm, because in my experience, almost every user doesn't care about privacy, even less open source versus proprietary, if it means switching application or something like that. So what's your plan actually to make the application so good that they will stop using the proprietary applications in favor of this?
Right. So the question was, how do we get people to use these free and open source applications so that they become the norm? And I think the answer here is, right now, if you look at the landscape of fitness apps in general, there's a ton of fitness apps, but no clear ones that people would recommend. And I think that creates an entry point for free and open source software because apps come and go. Apps are being canceled all the time. There's mergers, there's redesigns, there's all sorts of things, and there's no one clear app to use. And I think the advantage that the free and open source world has here is that really you can focus on building apps for a specific use case. And these apps then, because they're open source, even if the original maintainer leaves, can then be maintained if they're useful to people. And also we can have joint efforts like this exercise wiki that everyone can use. So really, I think we can grow communities in a much more efficacious way than closed source projects can, just because we share a lot of things among various open source projects. Any more questions? Yes?
One thing which seems a bit of a nuisance is that Garmin will only license their API use to commercial entities.
Right.
Is it worth registering one of these as commercial for purposes of getting the Garmin API?
So the question was whether we can, so the question was Garmin currently provides access to its API only to commercial entities. And it's a question of whether it's worth it to create a commercial entity to be able to access this API. And I would just say that I personally haven't specifically thought about Garmin. Maybe, again, this is something worth visiting in the future. It's also a question of whether it might not be better to just integrate with some resource that already plugs into the Garmin API so that you'd have your data from Garmin somewhere in some, some centralized piece of software. I know, for example, Google has its do tracker that like amasses all sorts of fitness data from everywhere, and you can plug into it. But it's something that we'll have to look into going into the future.
Maybe we can go the other way around. Convince Garmin to take in this
Yes.
without
Yeah.
being
Yeah.
commercialized. Right?
Yeah, we can potentially convince people, Garmin, to open it up.
Of course.
Yeah.
Great. Thank you. We're out of time.
All right. Thanks.
and if the backend doesn't have it, QEMU cannot send a get config message to retrieve the backend configuration. So it needs to know which features are supported by the backend. So they need this feature negotiation, which is initiated by QEMU side, and QEMU will send the features message to get the bits that are supported by the backend. The backend will fill the bit array with the features that it himself understands, and then answer to the QEMU message. And then once QEMU receives the response, it will match the features with the ones that he can support. I put here a few examples for VirtIO features and Vihos user protocol features. Take into account that there are some generic and some specific ones. I put a few here about specific about VirtIO GPU, and then this backend send FD that allows backends to send file descriptors back to QEMU. But there are many features, both generic and specific. The next step in the initialization is the VirQ configuration. So this is for the data plane, right? It's a shared memory. So what QEMU will do is allocate memory regions as shared huge spaces as it boots. And then it will pass these shared huge spaces as file descriptors to the backend, which will map into their own address space. And then after that, so they can both see the same memory regions, the VirtIO driver will reserve part of this memory for VirQs. So VirQs are basically like logical queues where the sender can write their message, their command that want the reader, the receiver to read. And they usually have different logical meanings so that you know what kind of messages are you retrieving from specific queues. And again, same with features, there are some generic and some specific. Like we have here the control queue or the event queue that are generic for most of the devices, but not all, but most of the devices. But then we have some very specific VirQs like the cursor queue, TX, and RX that are for GPU and socket respectively. And that we can log in, and we should have device available so our journey can start for the data. So in this part of the presentation, I'm going to focus in my experience with VirtIO Video. As I said, we have already the device accessible from the guest, and we will have an application running in the guest user space that want to interact with that device, right? In this case, we can assume that it's GStreamer, and let's say it wants to start a decoding stream, and then it will query some buffers, it will create some buffers, and then it wants to queue them. So for doing that, it will send this VideoC queue buff IOCTL, filling with some data that is required by the driver, and then the driver will handle the system called the IOCTL. Take into account that some operations that depends completely on the implementation of the driver are handled directly by the driver or completely ignored. But in this case, this queue buffer will actually trigger an interaction with the hardware. And when that happens, what the driver will do is take the information that has struck in the IOCTL and send a command and write a command in the VirQ that is specific for this type of communication. And for the queue buffer command, it will send this command receives queue, will write it in the shared memory in the specific VirQ, and then the backend will be able to read it. Take into account that the format is defined in the specification document. It varies for each VirtIO device. So this command receives queue is only for VirtIO video devices. Different will have a different set of commands. And the format is agnostic to the driver or device implementation by definition, so that you can have multiple implementations coexisting between them. As long as they adhere to the VirtIO specification, they should be able to understand each other. And then we left it where the driver brought the message in the VirQ, and then it will send a notification, and the backend will be able to read it from the VirQ, and then it will reconstruct the VirQ buff
the command. The information should be contained in the QL will be pretty similar to that the GStreamer sent in the guest user space. And then the device driver in the kernel will handle the request and interact with the hardware because it will receive the IOCTL, and then we have this final interaction here, and we have arrived to the hardware device. And that would be in most cases, but in some cases we need a response that is defined by the VRTO specs. Not all commands do. In this case, it does. These responses can be synchronous or asynchronous. Again, in this case specifically, it is asynchronous. So what we are doing is queuing this buffer in the hardware device, and once we start the streaming, the hardware device will fill the buffers, and once they are filled, it will launch an event upwards, and once the backend receives the event, it will pick it up and send the response back to the first the driver and then to the guest user space. So it's exactly the same path, but backwards. And that's the end of our journey. I think we have a few minutes, so I will give you a few hints for debugging, completely based on my experience. So the problem with this is that it's something fails or the communication misbehaves. Is not easy to debug because the problem might be in the guest user space, in the communication between the front end and the back end, or in the communication with the back end and the hardware device. So it's not really that easy to debug. So what I will say here are a few points. First, even if you are implementing the backend or focusing on the backend, it's good to know what the driver is doing. Then also, that depends on the backend, but in QEMU, most backends come with a -- debug option. Use them because they have a lot of extra information that are useful. Then also these two commands, strace, ftrace, I assume most of you are familiar with them, but if not, they are very useful to figure out what's going on. Strace is for signals, and ftrace is for inspecting the function flow in the kernel. Trace command is for ftrace. So they can be very useful to know what is going both in the guest or the host, so use them as much as you can. Then you can also run what I said we run in the guest user space. You can run it in the host too, and trace it to know that you are doing the same thing or the right thing in the backend. Then another good tip is use QEMU monitor and GDB debugger. And this is this blog post written by Stefan, and he gives very good hints to use both tools. If your Virt.io backend gets stuck somewhere, you don't know where, you can check this blog post and try to figure out. And nothing else, patience and good luck. And just to wrap it up, these are a few links that helped me when I started with it, and they are all good reads, including the Virt.io specification, the last one that has been upstreamed, which is 1.2. I think 1.3 is due for this next summer. And the last link is the patch that I posted in QEMU for the Virt.io video. So if you are curious or check it out and have something, please do. And that's it from my side. Any questions?
You said the Virt.io kernel driver, so that's actually its own driver module that runs in the kernel, and then it interacts between hardware devices like the video card. That's what the Virt.io, that's what its job is?
Yeah, so the question was that whether let me see if I can phrase it correctly. If the Virt.io driver is a kernel module that interacts with the hardware device in the host. Yeah. So yes and no. I mean, it does interact with the hardware device, but it does it through the backend. So it needs another Virt.io piece, which is the backend. So you can consider it the front end, and then it can send commands to the backend through the shared memory, and the backend will interact with the hardware directly.
externalizing the driver, moving it to a separate process, I guess, and hiding it behind a socket?
Yes, so the question is about the benefits of externalizing the backend into a different process. That's a difficult question. I mean, not difficult, but it can be long to explain. But long story short is about context switches. Like if you have, for example, the backend embedded in the QEMU process, every time you do a system call, you need to do a context switch to the kernel and then back again for the data. And if you are like the device is writing data into your buffer, you're gonna have to wake up QEMU, and it's a tough beast. So that's why it's better to externalize the backend to avoid these switches.
Okay, maybe I'll reformulate this slightly. It seems like they're very queue-centric. And have you ever encountered situations when you thought, why did we ever use the queue? We should have used the thread.
For
the socket and I don't know, doing some super complex multiplexing, demultiplexing, prioritizing messages.
But which queues are you referring to? Sorry.
This externalizing the driver and hiding it. Have you ever thought that like should have been something else rather than the queue, or you don't find it limiting?
So the question is whether the queue used in the backend is somehow limiting or could be a different option. I think it's not limiting. Like you don't write that many. The communication is not that fluent between the front end and the backend. You just write a bunch of messages there, and then you have a ring, and you are looping through the ring with the messages. So I think it works pretty well for what it has to do. I don't know. I guess I never gave that much thought into why it was done that way.
Right, I'm sorry, we're out of time. Thank you so much.
Hello. Yep. So exactly that. So that's the topic about the talk. So first of all, my introduction. So my name is Ricardo Carrero Cruz, although everybody calls me Ricky. I'm a principal software engineer at Red Hat. I've been there for almost 7 years now. I'm a member of the productization team at Ansible. We are responsible for building and delivering the Ansible products, and we're also, responsible for the installers and operators and other stuff. Previously to that, I was very involved into the OpenStack project as a whole at another company. Then I joined Red Hat with Ansible, and then I've shuffled around a bit. So I've been at OpenShift Engineering, CTO office, and I'm back to the mothership at Ansible because I'm really happy, to be back with my folks. So first, a little bit of introduction, because I'm not sure, I don't like to presume things. I don't know if you ever heard Podman. If not, so what is Podman? It's a container engine to build, run, and manage containerized apps. So, you can pull images from Docker Hub, Quay. You can build your applications. You have maybe a web app with your source code, and you want to create an image and push it. And you can create containers, run them, stop them, that kind of thing. It's obviously open source. We're Red Hat. We're an open source conference. That's what we do. Follows open standards like OCI for container images and runtime. So it will support things like run C, run, whatever, it's standardized. It's just like Docker, but different. So how is it different? Well, it was designed to support rootless containers from the ground up. One of the things that the Podman folks did is that they didn't want to have like Docker that runs as a daemon and as root. So the cool thing about Podman is that you can run a container as non-root, and basically if there was some sort of a privilege escalation and you could somehow get out of the container, you would still be running as the non-root user at the host. It's daemonless, unlike Docker, which has a client server architecture, which you connect from a client to the server, and the server spins up the container, and then it wires up the connection between them for the standard then start that out. It doesn't have any kind of daemon. It's just a fork and exec. So Podman spins the container runtime. The container runtime spawns the container, and that's it. So Podman, goes away. Docker CLI compatible. It aims to have the same flags as Docker. For the most part, you can even do like an alias for Docker, and Podman will just work. Cool things that it has. So despite being daemonless, you can still have like a Podman as a daemon if you want to access it, remotely. Maybe because you want to have a host machine with Podman running, and you don't want to run Podman from your laptop. You can still do that. That's managed by systemd. It's not Podman being a daemon. It's systemd doing that. Integration with systemd. That's another thing that the Podman folks wanted to put into the project. Maybe you have some legacy application which you have multiple services, and you want to have like systemd managing all of that. And my understanding is that there was some issue with Docker, and they didn't want to allow that. And Podman allows you to do that. You can have a Podman container which can leave systemd managing the services for you. This is actually another cool one that you can actually label your containers with a special label. And if you run a Podman auto update command, Podman will go to either an internal or remote registry, check whether there's a new image for your container. And if there is, then it will pull it and rerun it so it updates the container. You can also have like a systemd unit managing that if you want to have more automatic kind of things. It supports pods of containers. This is like, just in case you're not familiar, in Kubernetes you have like the single unit for execution is a pod. It's not a container itself. So when you want to have like containers that share the life cycle and you want them to share like the same storage and networking, you put them into a pod. So that's actually what gives I think, Podman the name. It's Pod Manager because it allows you to create pods. So you can create a pod, and then you put containers in them. So you can share networking or storage to have some communication between them. Generation of Podman pods from Kubernetes manifest. You can actually get something like a deployment manifest from Kubernetes and run a command, and then you create containers out of it. And the other way around. You can generate Kubernetes manifest from Podman objects, which is actually pretty cool. Now, another quick introduction for Ansible. Ansible is an IT automation tool. It's a tool that allows you to automate things for your infrastructure, whether it's deploying servers, configuring your servers, deploying applications, that kind of thing. It's open source with Red Hat. That's what we do. Very easy to learn and use. This is actually one of the cool things about Ansible is that it's the learning curve is like very low. It's like very easy to get going and automate things with it. Agentless. Some other similar tools, you have to install agents in your servers to actually run automation. With Ansible, it's not like that. You have something, you run Ansible from a bastion or control machine, as we call it, and you run automation against your target host. So you don't have to install anything. Providing you can SSH to it or use whatever connection plugin to connect to the device, you can just do it. Highly extensible with plugins. Everything with Ansible, it's plugin based. From the connections, you can maybe you have devices that do not use SSH. For example, Windows machines, so you have a connection plugin for WinRM, for example, or maybe you want to you have your host machine in inventory, which is the static file, but you want to somehow pull your VMs from AWS, so you have plugins for inventory. So pretty much everything in Ansible is plugin based. You can mix and match, and you can extend it. Use case for Ansible config management, install packages, set firewalls, create users, groups, that kind of thing. Infrastructure provisioning, you can create, VMs, containers, clusters, AWS, GCP, Azure, DigitalOcean, OpenStack, VMware. I mean, you name it. We have, a lot of modules for that kind of thing. Application deployment, if you need to deploy, your bare metal servers applications or containerized applications, or even, you can even create VMs with your applications, then push them into your cloud, and then you create instances from it. Orchestration, that's my favorite one, because Ansible is so simple and it has such a wide integration with different services. It can actually act as the glue to basically automate all the thing. ARI Cloud, all the clouds that I said, networking, you can automate your networking devices, your firewalls. We're also getting into the edge right now. So with Ansible, you put your content, modules, and playbooks, and roles, and all that into collections, which contain particular domain of automation. So you will have a collection for AWS or for VMware, that kind of thing. And you can pull that from Ansible Galaxy, which is a repository in the internet for basically browse and look for your content to automate your stuff. So this is the collection that there is for Podman. That's been largely developed by another fellow Red Hatter, Sagi Schneidman. He's done a phenomenal job, creating a very feature-rich collection for automate, Podman containers. Because it's not part of the Ansible core, it's available from Ansible Galaxy, so you have to install it with Ansible Galaxy CLI. It's a resource-based kind of collection, so we'll have resources for managing Podman containers, which you can start containers. You can even generate systemd units for those containers that you want to run. Modules for building, pulling images, logging to registries, whether they're internal, or public ones. Create networks in Podman. You also have a module for integration with Kubernetes, also for managing pods and volumes. And the use cases, You can build and publish container images, push them into Docker or Quay, whatever. You can deploy your containerized applications managed by systemd. You can actually, okay, so you run a Podman container, but also have a systemd generated, so you can start and stop it with systemd, which is a really nice feature. Because you can do pretty much anything with Ansible. That's another good use case. You can create an instance, then configure the instance with a role that will deploy a containerized application on it, then create an AMI from it, and then you have like a blueprint, an AMI which contains your containerized app, and you can create instances of it. Yeah, so you can manage your volumes and networks for doing backup and restore for your containerized applications, because you can actually not only create volumes, you can also infer and get information about your current Podman objects. You have info modules for all of that. And if you have like Podman containers running, you can also generate systemd units for it with it. And also, following that feature for Podman, it can also help you out to migrate workloads from Kubernetes to Podman and the other way around. I'm not sure, so this is going to be a hard one because, yeah, I don't have my, yeah. So yeah, so this is one word. So I won't be able to do the demo because I don't have in front of me the terminal. So I'm sorry. But if you go to the last slide, it will contain the link and some, yeah, I can even click here. Yikes. Yeah, so if you go to this link, you will find some playbooks and scripts that will have a very basic role that builds an image by using a role for based off an Nginx image. It will create a volume, push some HTML files on it, and then it will create that image with the AWS modules and then tear it down. So basically, it will depict how you can have a very basic role for creating your containerized application and reuse it for creating a cloud image, which you can use for launch your instances with it. And we're out of time. Yeah, so does the next one, does it have the same system for showing? Because I have another demo, another big demo on Sunday, and I would like to try out before.
Of course, sure. You know what? It's good to try it either in the morning
Sure.
Yeah. And we have Yara with us, and the topic will be the power of GraphQL. Go.
All right. Okay. How is it annoying to see a spinner and the application takes forever to load? Performance is crucial in user experience, and slow loading data can really hold an app back. That's why today I'll be exploring one of the tools to enhance the data fetching and data loading. It's called GraphQL. Do you have a pointer? This works, right? This should work like that.
First.
All right.
Oh, you don't have USB, of course. Sorry about that.
Oh, I have.
You have dongle?
Sorry, technical issues. I don't know. No, I don't have a. I'll see. Here. I think this should work.
Yeah, of course.
All right. Of course. Where is it? The shift. I'm just pressing whatever now. You know, never mind. Never mind, I will just use my keyboard. It's okay.
And it works. There you go.
All right.
Thanks.
So today I'm presenting, again, the power of GraphQL. So we're going to explore the powerful capabilities of this tool and how we can use it for API in modern application. But before I do that, quick introduction about myself, and it's not working again. All right. Quick introduction about myself. Hello, everyone. My name is Yara Debian. I'm Lebanese. I currently live in Barcelona, and I'm a software engineer at Factorial. So before I start about talking about GraphQL, I'm just going to go over real quick REST API. We all know about REST API, and it's like the go-to solution when you're dealing with data fetching and data manipulation. But with REST API, we can have some problems. One of them is the underfetching. And underfetching is when I'm requesting data, and to get all my data, I need to have more than one REST API request, because I'm not getting enough for one request. Also, we have the problem of overfetching, which is actually the opposite. It's when I get more data than I actually need in my request. So all of this can result in slow loading data, in the appearance of spinners, and we hate spinners in our application, in the reduced responsiveness of the web application, and overall the usability of the application. It undermines it. So let's try to solve this question, to solve this pain with GraphQL. First, what is GraphQL? GraphQL is a API query tool.
Okay, I found this on the web for Izzy Izzy. Check it out.
Sorry about that. It's my friend Siri. Siri, shut up. All right. So GraphQL is an API query language, and it has three main pillars. The first one is the single request property. And what do I mean by that? I mean that we can have all the data that you need in one single request, and we're going to see later how we can do that. The second one is the easy data manipulation, and the GraphQL supports precise and simple data fetching. And the last one is the strongly typed schema. And when I say strongly typed schema, we can think about it as a contract. It's a strict contract between the server and the client. So more about the schema. Here in my diagram, I have the schema that's defined. And inside my schema, I have all the logic, everything I need to know for my application. I have the objects, I have the models that I want. I also define the operations that I can do on my data. So the query, the mutation, everything. So what happens is the front end or the client, it requests some data, or it wants to manipulate some data. So it talks to the backend or the service. And what happens is the server needs to check with the schema, which has the contract with it, and to see what kind of operations are allowed and what kind of types are defined and everything. So everything happens inside the schema, and the DB is there just to provide the data or to execute some manipulation, some mutations for the data. Now, what is a schema and how we construct it? We need to understand something, which is the types. We have four main types in GraphQL. The first one is the scalar, which are the basic types. They can be integer, string, boolean. The second one is when I don't have the types already predefined in GraphQL, I construct something called custom scalars. And this is used to express some date or time variables. The last one, the third one, is the enumerators, which is when I have a discrete set of choices that I want to express, and I know what output I am expecting. For example, to define a role, I can define the role being an admin, or a guest, or a default, or a manager. I know what kind of output I'm getting. And the last one is the object. And the object is actually a combination of all the previous types and also of some objects. They're the complex data structure that when we see, we can actually understand. The last thing that I want to talk about is the query. And from the name of query, what is query is a function that used to request and fetch data from the GraphQL API. It's a really cool thing about the query is that, shut up, Siri. The cool thing about query is that it helps me define what I want, and it helps me to get the exact data that I need. So the thing here in this really simple query, I'm defining what I want as a response. So here I'm trying, for example, to get a post, and the query takes an argument as any function. Here I'm taking an ID, and I need the post to return the ID, the title, and the author attribute, for example. So everything is defined by the developers, and I don't have any surprises from the backend from what I'm getting, because I'm defining what I need. So it makes the API more efficient and more flexible for the developer. So I'm going to let that sink in for 2 seconds. And now that you have enough basic knowledge on the GraphQL and how things work, I'm going to jump to a quick demo. Suppose I have this weblog application. I know, design is my passion. So I have a user, I have some posts, and I have a friends list. Now suppose I want to render this page. What I will need is 3 requests. First one to get the user, the second one is to get the post, and the last one is to get the list of friends. Okay, so now suppose I want to take my application to the next level, and I want to have this kind of like a popover or a tooltip or something, and inside it I will be also displaying some information about the author of every post. So I will need 3 additional requests to get the user information. So that's all, it's more than 4 requests just to get this simple page. So imagine the amount of spinners I will be having now. That's crazy, and we hate that. We hate spinners. So let's try to solve this with the GraphQL. First, what I will do, I will start with my schema, just to understand how things are done. I have a user. I define the user attributes that I have, ID, name, email, whatever. And I also have posts that the user can see, or that they belong to the user. And what is a post is actually another object. Inside the post, I also define the attributes, and the post has an author. What is the author is actually a user. And lastly, also inside the user, I have a friends list. And what is a friend is also a user. So now we see how things are connected together. Now that I constructed my schema, I'm going to try to construct my first query. And what is this query doing? This query will try to fetch the page that to render the page that I have. And inside my query, what I have my argument, I have my ID. And again, I'm defining what I want. I'm telling the client is telling the server what it needs. So I'm telling here for the user, I need the user attributes, I need a list of posts, and I need a list of friends of this user. So all of this is being done with just one request, which is /GraphQL. So no more underfetching here. I don't need more requests just to get one simple data that I have. It's as simple as that. This is how my output would look like. Strict, basic JSON format output. I have all my information. I have an array of posts. I have an array of friends. As simple as that. Now one more thing. Imagine I decide in my application that I don't want to show the email anymore. I don't care about the email, and I don't need to render it. So basically, with REST API, I will have to accept it because this is my request to get a user. So what the backend is giving me, I'm going to have to deal with it. I'm going to have to parse it and do all the logic there. Or I'm going to have to change the logic in the backend. But with GraphQL, all I can do is just remove my email. I don't need it here. And this is how my output would look like. no email, no overload of data, no load of transfer, so no more overfetching here. I'm getting exactly what I need. So yeah, I'm gonna go just take a quick look again on my application. And if we look again, we can see that we have something common here. We have some common fields. They are all a user. And if I take a look again at my query, I can see that inside my query, I'm repeating myself here. I'm repeating the attributes again and again, and we hate repetition. And I think most of us are lazy when it comes to rewriting the thing over and over again. So what if we had a way to connect everything and just to group everything in one single query? And this query is gonna, every time I'm gonna call it, it's gonna just give me the information of a user instead of me repeating myself. Well, that's possible. It's possible with something called fragment. And what is a fragment? The only way, or the simplest way to think about fragment is like an abstraction. And it's extracting data from a query, extracting a subquery. And I can reuse it everywhere, like a puzzle piece. And I can reuse it in every query. And every time I'm using it, I know what it's going to get me. And I know the type it's going to get me. So for example, here, because I have the type user, I can construct a query called user fragment. And every time I will be calling this fragment, it's going to get me the ID, the name, and the email. So this is how my query would look like again. I would be just calling the fragment in both places, for the user and for the friends. Now, the also cool part about it is that it makes my code more maintainable and more modular. Why? Suppose I decide to make my application even more sophisticated, and I wanted to add a bio attribute here. Now, if I had the old query there, I will have to go to everywhere I'm calling the user and call the bio again. So, but with fragment, I can just add it here. And the bio will be requested everywhere I'm calling the fragment. So yeah, that's pretty cool. Now, everything I just explained and I went over can be possible, or it's kind of a bit complicated to do without Apollo client. An Apollo client is a simple library that's used to integrate GraphQL with our front-end projects, with React, Angular, or any other framework that we're working on. And it provides caching capabilities, and it makes it easy for developers to use GraphQL. I'm going to combine everything that we did. It's just simple JavaScript file. I'm sure if I'm going to run this, it's going to fail. But it's pretty basic to understand how things are connected. So I'm using my Apollo client here, and I'm importing my useQuery method here. And I'm going to use this query to actually call the query that I constructed. So I have here my query that I constructed before. I'm not going to put it here, the get user query. And what I'm doing, for example, here I'm defining a user profile component. And inside it, I'm calling the use query from Apollo. I'm passing to it my constructed query before, and also the argument, which is the variable, which is here the user ID. And what it's returning loading, which is a Boolean value, to know if it's loading or not, to know if I'm going to display the spinner or not, the only spinner, and the error field, and also the data. So this is how it's going to look like. I have the user. For example, I can define it, and I can be able to use it in my component, user.name, .friends, .post, everything that I'm actually returning in my query. Yeah, pretty cool. And there is more. I haven't even scratched the surface of GraphQL. We still have the mutation. It's enough. 15 minutes is not enough to talk about that. We also have the pagination, which is used for extensive data. And the error handling, as seen before, it's here because the GraphQL, it dedicates just a field for the errors in every response. So it's so easy to handle it and to parse it and all of this. So yeah, I highly request or advise you to check GraphQL. It's a really interesting tool to have, and it can take really like API management and data management to the next level. And to check that, there are a lot of tutorials online, a lot of documentation. One of them is the official documentation for GraphQL and the official documentation for Apollo as well. And there are a lot of free resources on the internet to check. Last but not least, I just want to go over some real-life use cases of GraphQL. starting by Facebook, which is, I forgot to mention, is the creator of GraphQL. And Facebook is using it for the Instagram application. Also, we have GitHub that's using GraphQL to construct their public API. We have Twitter using GraphQL for their Twitter Lite application. And Twitter Lite is the application used for slow connection environment. So they're trying to make the application more performance and requires less rendering. So this is great when they try to escape the overfetching and underfetching in Rest. And lastly, also, Airbnb is using it to unify all the API in one. And it makes it easy for developers to maintain Airbnb application. So yeah, we can see that GraphQL has made a huge impact in the tech industry. And let's try together to unlock the power of GraphQL. Thank you. What time?
Any questions for Yara?
Yeah. Hi.
Hi.
How do you validate the query according to the defined schema?
Sorry, I didn't hear the question.
How do you validate query according to the defined schema?
I don't, but the schema does it itself.
Inside the library or you write?
It's Apollo. It's the integration with Apollo that validates everything. That's the thing. I pass only my arguments to it, and the schema is how it's defined, because I'm defining in my schema my user type, for example, and I'm defining the user type is always, like the ID is always an integer. And I don't know, the name is a string, or the date has this format. So every time I'm sending a request with my Apollo client, it's gonna check this query. Okay, it's gonna check what kind of type I'm passing, for example, and it's gonna return it for me. And if anything is not matching, it's gonna throw the error by itself.
Is it possible to return a partial response for the request, for the query?
Partial response for the query. It depends what I'm sending. This is the thing. I define in my query what I need. So if I need a partial response, I just need to tell it I need it partial. So I only define it.
Okay, it's possible according to principles of GraphQL.
Yeah.
Yeah, thank you.
You're welcome.
We're out of time. Great. Thank you. Thank you.
All right. Thank you.
Sorry about that,